Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so in today's lesson, we're going to be looking at the Gauteng province June examination paper for the grade 12 for maths, of course. So we're just going to be going through this question in preparation for the exam that you'll be writing on Friday. So take note that it's not only for the Gauteng learners. You can also use it in whatever province that you are in, because the curriculum is just the same in all 9 provinces, right? So if you are in Limpopo, you are in Mpumalanga, or any of the other provinces, do not skip this video. It can also be helpful. Right, so these are the instructions and informations that you'll be going through with your invigilator, meant to say. So you go through all these instructions here, blah, blah, blah. And then, okay, we have our question 1 here, which of course we know it is our algebra format. But then the one thing that I want you to note, guys, is that it is not compulsory for you to write those questions in chronological order. What do I mean by that? Are not supposed to write question 1, then question 2, question 3, just because your exam is like that. If you feel like you understand question 5 much better, you can just skip to question 5 and do question 5, right? So, okay, that is to say that you must focus on having to collect marks, right, rather than having to fight to finish the exam. Yes, you should try to answer all the questions, but then try to answer the ones that you understand first, right? Because a lot of you learners, you make the mistake of having to stay too much on a question that is giving you a problem. And then the more time you spend on that, remember the time is being used up. And then now by the time you get to the questions that you really understand, it's probably 15 minutes for you to conclude the exam, right? Which is not enough. Okay, so now the strategy that you want to use is you want to run quickly to the questions that you understand. If you feel like question 7 is much simpler to you, run to question 7, write question 7. As long as you indicate on the paper that this is question 7, this is question 5, question 4, then obviously those ones will be marked, right? So it's just you indicating. If we are marking question 1, we're just going to extract the paper that's written question 1. Another useful tip is just to write those questions in separate pages, right? So every time you see the instruction that says start on a new page, that's for that reason, right? So you can write question 1 on that single leaflet paper, and then also another question on that single leaflet paper. And then when you are done, you can then compile them in terms of the chronological order, right? But then you did not write in chronological order. You just compile them and then submit in chronological order. Right. So that is the advice that I want to give you right there. Make sure that you focus more on having to collect marks, right? 3 hours can be a very short time when you are writing your exams. Okay, enough with the talking. Let's just start with our question 1 now. We have 1.1. It says solve for x. For 1.1.1, we are given a very straightforward question. So you have probably seen this question most of the time, and then we already know the drill with this kind of questions. So what you need to do here is do not make the mistake of having to multiply inside here. We do not multiply. Already this is in standard form. We have 2x bracket 3x plus 4 is equals to 0. So what you are supposed to do is take this 2x here, equate to 0, and then take what's in the bracket here, and also equate to 0, right? Then obviously here, if you divide both sides by 2, your x will be equals to 0. And then here you need to transpose the positive 4, it becomes negative 4. Divide both sides by 3, then you have your x is equals to negative 4 over 3. Now for this 2 marks, that means what they're going to mark here is the x is equals to 0, and the x is equals to negative 4 over 3, right? So that's basically what you do with that question right there, right? Nothing crazy, just that. Okay, so now we have 1.1.2. says 2x squared minus 4x is equals to -1. Correct to 2 decimal places. Now we know every time we are given correct to 2 decimal places, we know that we have to apply quadratic formula, right? So I'm just gonna erase here. Hope you have noted down already. Remember that you are writing this along with me, right? You are writing this along with me. Then this is 1.1.2. We know that for that one, we must apply our, but then first, before we can apply the quadratic formula, we need to make sure that it's in standard form. Now we can see the -1 here, which we need to transpose over to this side. This is going to be 2x squared minus 4x, and then plus 1 is equals to 0. So the goal is always to get this in the format of ax squared plus bx plus c, which is the quadratic equation, right? So that we can then use the quadratic formula. Now at this point, we can see that our a is 2, and then our b is -4, then our c is equals to +1. So what you want to do is you want to write this and say x is equals to negative, b plus minus, and then now you have a b squared minus 4ac, right? So if you ever forget this formula, do not be ashamed. You can just go back, you can just go to the last page of your question paper, which is the data sheet or the information sheet. So you will have this formula, right? So you do not have to say that means I don't know maths if I forget this formula. Can always go and check those formulas. Remember, it's not like grade 11. In grade 11, you are not provided with the formula sheet, but then in grade 12, you have the formula sheet, so you might just as well use it. Then, okay, so we have that, and then 2 multiplied by 2. Right. Now, at this point, you do know that in your calculator, you will punch all of this with the positive sign first and then get the value. So with the positive sign, we get x is equals to 1.71. And then you're going to have to go back here and change this to minus. So when you change that to a minus, you get a negative. You get 0.29, not negative. So 0.29. So these are your two values here. And then what do they mark? They mark having to write this in standard form, right? So very important. First, if you get it into standard form, it's a mark. And then if you substitute into this correct formula here, it's a mark, right? And then the other 2 mark is for the values, right? So just like that, you have your 4 marks, right? So take note of that and know where your marks are, right? Okay, so that's it right there for 1.1.2. We have our 4 marks in the bag. Okay, so let's go over 1.1.3. We are having an inequality there, which from here we can see that we have 1.1.3. 1.1.3, this is x minus 2 and then square, greater or equal to +1. Now, obviously, the square here means that we should expand this twice, right? So x minus 2 and then x minus 2, right? Greater or equal to 1, right? So what you want to do here, obviously, is to FOIL here. So the x multiplied by x, the x multiplied by -2, the -2 multiplied by that, and then like that. So obviously, this is going to give you x squared, and then x multiplied by -2x is -2x, and also this one is -2x. So when we add them together, that's -4x. Then the -2 multiplied by -2, that's going to be +4. And right away, we can transpose the 1 here. So that's -1 greater or equal to 0. Now, when we continue, we're going to have x squared minus 4x, and then 4 minus 1, that's +3, greater than 0. Now, you can factorize this, or you can use the quadratic formula. If you are having a challenge with factorizing, then you can always use the quadratic formula, right? Because you already know about the quadratic formula. So there's no need for you to lose a mark just because you can't factorize, right? So this is x and then -3, and then x minus 1. Greater or equal to 0. Now you will remember that if the inequality sign is facing that direction, I said this a couple of times, if the inequality sign is facing that direction, then your solutions will always have to be like this, right? Your solutions will always have to be x, less than or equal to the minimum value, or x greater than or equal to the maximum value, right? So this is where you have separate values outside of the critical values whenever it's facing that side. But then when it's facing this other side, right, when it's a less than sign, then your solutions become like this, where you have the minimum value here and then the maximum value like this. So always note, guys, always note. Always note. Now, obviously, if you don't have the equal here, that means you will remove this, right? You will remove the dash right there, right? Okay, so basically that means my solution for this one should be, remember my critical values are supposed to be what? Positive 1 and then 3. How do I find the critical values? It's more like solving for x. If I were to solve for x, I would have to take this bracket and equate it to 0. That would be x is equals to positive 3. Take this bracket, equate it to 0. That would be x is equals to 1. So my critical values are like this. Start with the minimum value, then the maximum value. So that when I write, this becomes what? This now becomes x. Is that visible? No. So this becomes x less than or equal to the minimum value positive 1, or x greater or equal to the maximum value positive 3, right? And then some others prefer to just draw it like this, whereby you will just make this one much more visible because it's included. So this is your 1 and this is your 3. Then you have to shade over here. Then you have to shade over here to indicate that the values that satisfy the equation are the values that are outside the critical values and also including the critical values, right? So others, again, might still choose to do it like this. So many ways to express this, guys. So many ways to express this. It's all up to you. So you can still have the 1 here, positive 1 in the 3. And then you show that the values that are accepted are the ones outside the critical values. Right, so that's it with having to tackle that inequality question there. Okay, so 4 marks in the bag. How do we get the, where do we get the marks? So standard form number 1, getting it into standard form will give you a mark. And then the factors, having to factorize here, will give you a mark. And then I'm not sure if you use quadratic, whether they do give you a mark, right? Not really sure if maybe you forfeit a mark for using the quadratic, but maybe. So because maybe they would be checking if you can factorize. And then it's 1 mark for the critical values. And then also the answers here, having to come up with these answers, it's a mark, right? So 4 marks like that. Okay, then given the equation root x minus 2 is equals to 4 minus x, and then 1.2.1 says without solving for x, show that the solutions lies in the interval, right? So, okay, now note this. If we want to show that, we can show that this here, we have square root of x minus 2. Remember, they say without any calculation. So this is a 4 minus x. Now, what I can argue here is the fact that this here, inside here, the x minus 2 should always be greater than or equal to 0. Now, we do know that because if you are to take note of the SAD rules, remember in a SAD, you should never have a negative here. Whenever you have a negative SAD, then we do know that if you have negative a, this is supposed to be a complex number, which is undefined, right? According to the maths level that we are in. So which is undefined. So in order to always have this being defined, then we must always make sure that this expression inside here must be greater or equal to 0, right? So that's the first thing. So we always make sure that our x minus 2 is greater or equal to 0, right? But then again here, in that case, this also must be 4 minus x greater or equal to what? To 0, right, as well, right? So meaning that if we are to look at this, right, so check this. Let's say we are trying to solve here. This would mean that if this is equal to that, this will be x and then greater or equal to what? To 2. right? And then if we are to solve this one right here, this would mean this is negative x greater or equal to negative 4, right? Which if we divide by negative 1, remember, I am aware that they said we must not calculate, but then I'm trying to show you this. This is x less than or equal to what? To 4. Remember, when you divide by negative 1, the inequality sign changes. Now, if we are to interpret this, this means when x is greater than or equal to 2, which is this, greater than or equal to 2. Remember, how do we read this? This is when x is greater than or equal to 2, but x is less than or equal to 4. And then voila, that's how you get it, right? So you can just argue with this. You can just argue with this. So you just have to argue with this, the fact that your x minus 2 should be greater or equal to 0, and then also your 4 minus x should be greater or equal to 0. Then in that sense, that means that your solutions should be between 2 and 4, right? Because if you are trying to put other values that are outside the critical values, let's say, for example, 1. If you put 1 here, this is going to be 1 minus 2, which is negative 1, which is going to give you an undefined value here, right? And then also, again, if you say 4 minus 1, this is now equal to 3, which is not equal to that. Remember, it must be an equation, right? Again, if we can test with another number that is outside the critical values, let's say, for example, we test with 5. So this is going to be 5 minus 3, which is going to be root 3, right? 5 minus 2 meant to say, which is going to be root 3. But then this side here, if we say 4 minus 5, this is going to be negative 1, which again, we can see it's not equal. So that means the values that can satisfy the equations are only the values that are between 2 and 4, right? So to argue like that, it's a mark for each, right? To argue this and to argue that, it's a mark. Then, okay, so we have it like that. And then now 1.2.2 now is asking us to solve the equation. It's asking us to solve the equation. So we are going to have 1.2.2. This is root x minus 2 is equals to 4 minus x. Now, obviously, we know that the problem is that we have a square root here. So the first step is to obviously get rid of that. How do we get rid of the square root? We square both sides. But then we know the effect of the square root in the effect of the square in something that has a square root is just to remove that square root. So this is going to be x minus 2, right? And then the effect of the square in this expression here is that the expression will expand. So 2 times. And then x minus 2, 4 multiplied by 4, that's 16. 4 multiplied by negative x, that's negative 4x. And then also this is negative 4x. When you add them together, that's negative 8x. And then we have positive x squared, right? Then we can have x squared. Let's just transpose all this to that side. So we have x squared minus 8x minus x plus 16 and then plus 2. Note that I just transposed all of this to that side and then flipped it over. Then this is x squared minus 9x. The 16 plus 2 will give us 18 and then is equals to 0. Again here, you can either use the quadratic equation or factorize if you know how, right? And then which means now we are going to have what? What are the factors of 18? When we multiply them, we're going to get 18, but then when we add or subtract them, we're going to get 9. So factors of 18 are 1, 2, also what? Not 4, 3, and then 6, and then 9, and then 18, right? So usually we know that it's the factors that are in the middle right there. So 3 and 6. So x minus 6 and then x minus 3, because we see it's a positive, but the middle term is negative there. So equal to 0. Remember, if you don't want to go through all the trouble of finding factors, just use the quadratic formula. So x is equals to 6 or x is equals to 3. And then just like that, we have our solutions right there. Okay, marks, where are the marks? The marks here, number 1, it would be having to square both sides. Having to square both sides, it's a mark. And then having to then write this in standard form, it's a mark. And then having to get the factors, it's a mark. And then your answers is also a mark. Right. Then with this question here, almost forgot that. With this kind of questions here, you always have to test out your values. It is possible that not all the values would actually satisfy the equation, right? So we have x is equals to 6 and then x is equals to 3, right? But then you might find that you might find, so this is a mark for factors. The factors are this. So you found x is equals to 6 and x is equals to 3. But you might find that one of the factors here do not actually satisfy the equation. So you have to come back here and back test. So this is root 6 minus 2. And then what you want to prove is that is the left-hand side equals to the right-hand side when you calculate. Then we have 4 minus 6. The 6 minus 2 here will give us root 4. And then the 4 minus 6 will give us negative 2. But then square root of 4 is positive 2 and not equal to negative 2. So now we do know there's always that argument here that square root of 4 can be written as plus or minus 2. But then here we are just taking that the square root of 4 will be a positive, right? So everything that gets into the square root here must come out as a positive. So because this is giving us positive 2 and that one is giving us negative 2, that means the left-hand side is not equals to the right-hand side. So I must then come back here and cancel off this value here. So I must then argue that x should not be equals to negative 6 because in that way, we don't have an equation. The left-hand side will not be equals to the right-hand side. Now, obviously, we know that if that one does not satisfy, obviously the other one must satisfy. But then let's just put it to the test. And then this is 3 minus 2. And then 4 minus 3. So square root of 3 minus 2, that's square root of 1. Then 4 minus 3, that's positive 1. Square root of 1, again, we must always take the answer that comes out of here as a positive. Like the way you do it in a calculator. Your calculator will not show you plus minus. It will show you positive 1, right? So that's 1, and then that's 1. So yes, the left-hand side here is equals to the right-hand side, meaning this one is correct. So the fourth mark will come from cancelling out this one, right? So if you cancel out, so if you did not cancel, that means you are getting 3 out of 4. But if you then come back and then cancel off the 6 here and say x is not equals to 6, then that's your fourth mark. Okay, so I hope you understand that. So make sure on Friday, you have these things detailed out. Okay, so 1.3 now says solve for x and y simultaneously. Solve for x and y simultaneously. Now, the method to tackle your simultaneous questions is always to try and solve from the equation that looks the simplest. In most of the cases, you'll be given a linear equation and a quadratic equation. Now, always try to solve from the linear equation. It is much simpler. So what you want to do is write this. So you have your 3x plus y is equals to 2. And then you're going to label it equation 1. Then you write the other one, y squared is equals to 2x squared minus 1. And then you're going to label it equation number 2. Right. Now, at this point, what do you want to do? You want to write your y as the subject of the formula. So we choose this one as the simplest equation to work from, right? So it's much simpler to even make a y the subject of the formula. Do not try to make x the subject of the formula because as you can see, there is a 3 here. So if we want to make it the subject of the formula, we would have to divide by 3, which will create a fraction. Once you create a fraction, you have overcomplicated the equation again, which is not advisable. It's a recipe for disaster. So now you have y is equals to 2 minus 3x. So you just simply take the 3x, transpose it over to that side. Now you have equation number 3, and it is expressed in terms of y. So what does it mean? Now you can take this expression here and substitute it to this equation, right? So you can then now say substitute equation number 3 into equation number 2, right? So that means where you see y, you need to replace by this expression here. So this is 2 minus 3x and then square. is equals to 2x squared minus 1, right? Now, obviously, we know this means expand. So we have 2 minus 3x, 2 minus 3x equal to 2x squared minus 1, right? So follow, right? When we multiply here, we are going to have 4. We say 2 multiplied by negative 6, 2 multiplied by negative 3, it's negative 6. And then also here, negative 6. So that means middle term will be minus 12x, right? So it's just a matter of multiplying here and then doubling. So 2 multiplied by negative 3 is negative 6. Double it, that's negative 12. Then negative 3 times negative 3, that's positive 9x squared is equals to 2x squared minus 1. So now at this point, you want to get this into standard form. So you have your 9x squared minus 2x squared. So you just transpose this over to this side, minus 12x, and then we have plus 4 plus 1, right? Remember, when you transpose, it changes the sign. 9x squared minus 5, minus 2x squared. My brain just runs fast to the answers. 5x squared minus 12x, 4 plus 1, that's 5. Oh, no. This is 7. Hey, my maths there. 7x squared minus 12x plus 5 equal to 0. Pardon me there. Okay, so when you factorize this, of which if you cannot factorize, that means you can use the quadratic formula as well, right? So 7x minus 5. Do not crack your skull trying to factorize, guys. Factorization should have been mastered in grade 10. If you didn't master it at this point, there is no use in trying to crack it now. Focus on other things. Then x is equals to 5 over 7, or x is equals to 1, right? But then we know that we are dealing with simultaneous, so we are not done. We should also find the values of y, right? So to then find the values of y, this is what we're going to do now. So to find the values of y, we need to go back to equation number 3, right? So we already have our x coordinates, and then we can say, okay, so I'm trying to make space for this one here. Okay, let's do it here. Right. So, okay, to then find the y values, I can say, let me argue for when x is equals to 5 over 7. So that means using equation 3 here, I will say y is equals to 2 minus 3, and then 5 over 7. So my y here would be equals to what? If I am using that one, so that means it must correspond to what? It must correspond to negative 1 over 7, right? Or if my x is equals to 1, then I will simply say y is equals to 2 minus 3 times positive 1, which my y is going to be negative 1, right? So there we go, right there. So I have solved for x and y simultaneously, and that's my 6 marks right there. Okay, where do I get the marks? Where do I get the marks? Subject of equation, right? Making equation number 3, it's a mark. And then having to substitute that expression here, it's a mark, right? And then having to get this into standard form, solving all the way, then I have a mark. So now I have 3 marks, and then having to get the factors, right? So factors here. So the factors are these ones here. It's a mark. And then having to get the x values, both of them correct, it's a mark. And then having to get the y values, both of them correct, it's a mark. How many marks? 1, 2, 3, 4, 5, 6, right? So that's where your marks are. So that means if you use the quadratic equation, I think in all these questions, you'll be forfeiting a mark, right? So you'll be forfeiting a mark, right? Okay, so you just have to live with that. You just have to live with that. Okay, so if r plus 2x is equals to a, so we are now on 1.4. If r plus 2s is equals to a and r minus 2s is equals to b, prove that rs is equals to a squared minus b squared over 8. Now, these questions here have a tendency of just looking difficult. They just look difficult. They're not difficult. You know, you know that one person that looks scary, but when you get to know them, they're not as scary. Actually, they're the most kindest people that you have ever met, right? So these are those kind of questions here. Look scary, but then they're not. And then this is, you're just going to say, I already have my expression for A, and then I have my expression for B here. So I can start by saying for 1.4, I have RS is equals to A squared minus B squared over 8, right? Now, looking at this one, you can see this is a difference of 2 squares, right? Mainly because this is A squared, B squared, and then there's a minus in between. So we know this can be written as A plus B, and then A minus B, and then over 8. So that's your RS right there. So now that means RS. Now remember your A is what? We must express this in terms of this. So basically here, if we can put it like this, we are trying to prove that the right-hand side will be equal to the left-hand side. So this expression here for the right-hand side will be equal to the RS. So eventually when we solve it, we are going to get RS. So let's begin now. Let's begin. Let's shift. Then A, this is R plus 2S. And then what's B? So I'm going to say minus. So note, careful with this. So let me use square brackets here. And then minus, remember I'm subtracting. Oh, it's plus. It's plus for the first bracket. It's plus for the first bracket. So I'm going to say plus R minus 2S, right? So close it off like that. And then let's look at this one. Now I have R again plus 2S, but then this time around, I am subtracting, so minus the expression. Note that when I'm subtracting an expression, I need to put it inside the bracket. So that's R minus 2S, and then close the bracket, then close the bigger bracket, over 8, right? So, okay, let's follow through now. Let's follow through. So that means here we obviously can see that the ones that will cancel are these ones. So 2S minus 2S. And then we only have R plus R, which is going to be what? 2R. So follow 2R. But then remember, it's inside the brackets. And then here, obviously, we're going to have R minus R, right? So the R minus R will cancel out here. And then the negative times negative will give us positive. So that means we end up with 2S plus 2S, right? So if I can just write it so that you don't get confused. So we have R plus 2S, and then this negative gives us negative R, and then plus 2S. I hope that makes sense. Over 8. And then this is equals to what? 2R, and then now C. That's the R and the R cancelling out there. And then the 2S and the 2S here will add. So hambanami. Then this is 4S over 8. Then what's 2 multiplied by 4? That's 8. But then 8RS over 8. Now the 8 and the 8, they divide out, and then we are left with what? With RS, which means yes, the left-hand side is equals to the right-hand side because we just got that RS there. Then voila, 4 marks like that. Okay, so C again, it was a very easy question to tackle. But then if you can just look at it, you might say, yo, this is a very difficult question. Only the genius of the class will get it. But then that's not true. So, okay, you're going to get a mark for the substitution of A and B, right? So substitution of A and B will get you a mark. And then having to expand will get you a mark, right? So having to expand will get you a mark. And then having to simplify will get you a mark, right? So actually expanding like this is okay. So let's see. Okay, I did expand here. So the mark for expansion for me is right there. and then having to do this, and then right there, and then my simplification. So that's 1, 2. I'm already at 4 marks right now. Yes. So they just gave a mark for substitution of A and B, the expansion 2 marks, and then a mark for simplification. Okay, so done with the first question. Question 1, done like that. So 26 marks in the back. So you just want to at least get 80%. If you want to do well in your paper 1, make sure you master your algebra, because everything in paper 1 is just algebra. We know from just marking question 1, the performance that we're going to get from all the questions throughout, right? So if a learner scores about 70% or 80% in question 1, then there is hope that they're going to do well in the exam. So question 1 is very important because this is your basic, right? This is your basic. Okay, so let's now move to question 2. Question 2 says, given the arithmetic sequence. So now we are on number patterns. Given the arithmetic sequence, 2.1.1 says, determine a simplified expression for Tn. Okay, so what we are going to do now is obviously take this 85 and then, so let's see. We have the 85 here, the 82, the 79, and the 76. And then what's the common difference here? So from 85 to 82, we obviously subtract by 3, right? If in here, subtract by 3. If in here, subtract by 3. So that means the common difference is 3. So we then now going to say Tn, we know it to be what? A plus n minus 1 and then d, right? So what is our Tn? What Tn? We are going to say Tn is equals to A, that's the first term, 85 plus n minus 1, and then d is negative 3. So Tn will be equals to 85, then negative 3 multiplied by n, that's negative 3n, negative 3 multiplied by negative 1, that's positive 3. Then therefore our Tn is supposed to be negative 3n plus 88. And then there we go. Right. Okay, so just as straightforward like that. That's how you were supposed to solve that. Okay. So now, 2.1.2 says, which term will be the first negative number in the sequence? First negative number means what? So first negative number means a number Tn where Tn will be less than 0. Remember, all the negative numbers are less than 0, right? So that means if you have to interpret this mathematically, it means where Tn will be less than 0, right? Okay, but before we get to that, let's see the marks here. How is the 3 marks distributed here? So for finding with the D value, that's a mark. And then having to substitute the values of A and the D, it's a mark. And then having to get the answer here, your Tn, it's a mark. Right. So now for 2.1.2, obviously, we understand this means Tn must be less than 0. Okay, so what do we do now? So that means for 2.1.2, this is what we do. So for 2.1.2, it's just simply taking the Tn, which is that expression negative 3n plus 88, and say less than 0, right? So this is going to be negative 3n, and then the 88 will obviously go over to that side. Divide both sides by negative 3, then our n should be greater than 88. Remember, when we divide by a negative, the inequality sign changes. So n should be greater than 88 over 3. But then 88 over 3 in your calculator, what does it give you? So if you say 88 divided by 3, you are getting something like 29.33, right? Which we do know that a term cannot be a decimal or a fraction, right? So what is the next term that is greater? What is another integer? What is an integer? The first integer, I meant to say, to be greater than 29.99 is what? So it's obviously 30. So that means T30 will be the first negative number, will be the first negative term. The first negative, T30 will be the first negative value or number, right? Because it should be, remember they're saying it should be a number that is greater than 29.33. So the first integer value that is greater than 29.33 is obviously 30. Right, then meaning from 30 going all the way up, the terms will now start to be negative. So, okay, that's the meaning of that right there. Okay, then we have a very interesting question here in 2.2. It says a quadratic pattern, a sequence with a general term Tn has the following properties, right? And then we are given that T11 is 190, right? And then Tn minus 1 is 4n minus 3. So we do understand that the Tn minus 1 is equals to 4n minus 3, represents the first difference. So, okay, now this is Tn minus 1, right? Which is representing the first difference, and then it's equals to 4n minus 3, as we can see with this expression. Remember with this, if we have a quadratic pattern, let's say it's a x, y, z, right? Then what follows is that here, y minus x must give us the value here, and then z minus y must give us the value right here. And then obviously, this would be the first difference, and then this would be the second difference. So let's say b minus a here gives us the value, let's say f, right? So that means this would be the second difference, which is a constant second difference, right? So what we're going to do here is, let's try to find the values right here. Let's try to find the values of the first difference. So the values of the first difference will be what? If we just use this expression here, that means in order to get T1 of the first difference, let me indicate first difference, not of the quadratic pattern. So because this expression here is for the first difference, then 4 multiplied by, remember the first difference, how do we know this is the first difference? The first difference is usually an arithmetic sequence. And if we can take a look at this formula here, we can see that this is the formula for the arithmetic sequence. So that's 4 multiplied by 1 minus 3. So which will give us what? So n must start from 2 right there. So 4 multiplied by 2, then minus 3 to get T1. So where n is greater or equal to 2. So 4 multiplied by 2, that's 8. 8 minus 3, that's 5. And then to get T2, we can say this is 4 multiplied by what? 4 multiplied by 3, then minus 3. So T2 will be 4 times 3. That's equal to 12. 12 minus 3, that's 9. And then to get T3, we can say that's 4 multiplied by 4 minus 3. So this is 16 here. 16 minus 3, that's going to be 13. So we have our second difference, our first different terms. So that's 5, 9, and then 13. And then we can find our constant difference from this. Our constant second difference, 9 minus 5 is 4. 13 minus 9, that's 4. Right? Now at this point, check this one out. Want you to follow this. I want you to follow this. So we now have the 5, 9, 13, and then we have 4 here, and then 4 here, right? So what we are looking for is the first term here, T1, right? What we are looking for is T1. But then we know that this one here, the second difference is always equated to 2a. And then the first difference, 3a plus b. So second difference to 2a, first difference to 3a plus b. Then T1 here has to be equated to a plus b plus c. Okay, which means now this is what we are going to do. Note this. So this is how we are going to solve that. We are going to say, let's now work it out and say 2a is equals to 4. Divide both sides by 2, then my a is equals to 2. And then if I take it over to the side, that's 3 times 2, and then plus b is equals to 5. So this will give us 6 plus b is equals to 5. Then b is equals to 5 minus 6, which b should be equals to -1. Now, obviously, the problem is with getting c. We don't know the value of c. But then we know that Tn should be equals to an squared plus bn plus c. Right? We are given T11 here, which is what? 190. And then our a value is 2. And then we can just substitute 11 here. And then b is what? -1. So -1. And then here we are just going to substitute 11. Then what we don't have is the value of c. So we can just say plus c here. And then this is 190 is equals to, if we do the maths right there, this will give us 242 and then minus what? 11 plus c, right? Now 242 minus 11. And then if we transpose it over to the side, so to get c, we're going to have to say 190 minus 242 plus 11. So c will give us what? -41, right? So just like that, we now have our Tn. You see that? So Tn now will be equals to what? So Tn now will be equals to, so Tn will be 2n squared minus n minus 41. Right. So that means to get T1, I need to say T1 is equals to 2 multiplied by 1 square minus 1 and then minus 41. Right? And then I can simply just get my T1 like that. So if I punch all of that into the calculator, my T1 becomes what? -40. Right? And there we go. And there we go. That's it. Right? So that's it right there. Then you have your value for T1 is -40. And then yes. So that's how you are supposed to solve that. That's how you are supposed to solve that. So there was a mark for finding the first difference. Mark for finding the first difference here. And then there is a mark for the value of A. So after we found the value of A is equals to 2, the mark for the value of B. And then there is a mark for the value of C. And then there is a mark for the value of T1. So how many marks was this? 5. So yes, for the value of T1. So 1, 2, 3, 4, 5. There you go. There you go. Pretty interesting question there. Now, the sum of the first 50 terms of an arithmetic sequence is 1,275. Calculate the sum of T25 and T26. Note this, the sum of the first 50 terms of an arithmetic sequence. So that means if we are to express that, that's S25, right, is equals to, so obviously, okay, let's start with Sn, the formula. So also the formula, you can find it from your data sheet, just the last page of your question paper there. So this is 2a plus n minus 1, and then d, right? So note we are solving 2.3 here. So, okay, now S25 is what? 1,275. So let's just say 1,275. And then we have here 50. So it's a sum of 50 terms. 50 over 2. And then we don't have the value of a, 2a. But then here the n again is 50, so 50 minus 1. We don't have the value of d. As we can see, we don't have a pattern, right? They just told us that a certain pattern, and then d here. Now, this is 1,275. 50 divided by 2, that's 25. And then in the bracket, I have 2a, 50 minus 1, that's 49. So that will be 49d, right? Then obviously, the first thing that you want to do is get rid of this 25. So we can divide by 25 both sides. And then what's going to be 25 divided by 25 there? So this is going to give us 51, right? So we have 51 here. And then this is 2a plus 49d, right? So, okay, now, obviously, there is nothing creative that we can do at this point. So let's just term this equation number 1, right? So we're just going to label that equation number 1. Now, let's focus on this one. That calculate the sum of T25 and T26, the sum of those. So that means add the 25th term and the 26th term, right? Now, we have a way of expressing T25. T25 would be expressed according to our Tn formula. So let's first write that one. So Tn is a plus n minus 1d, right? If we were to express T25, this would be T25 is equals to a plus 25 minus 1, and then d, which will give us a plus 24d. So this would be expression 1, right? And then again, if we were to express T26 now, using the same formula, that would be a plus 26 minus 1, and then d. So this would be a plus 25d, right? Okay, so this is equation 2, this is equation 3. Now, remember what we must do. We must add those ones, right? So T25 plus T26 will give us what? So that is supposed to give us a plus 24d plus, because that's what they're saying. The sum of T25 and T26 is simply just adding the 2. So we have the expression for those. So that's a plus 25d. Want you to look at this. Again, it's one of those questions that look difficult, but then they are not. Right, so a plus a, that's 2a. 24 plus 25, that's 49, right? So that means T25 plus T26 is equals to 2a plus 49d. But then what is also equal to that? You see that expression number 1 here, or equation number 1, is also equal to that. So the 2a plus 49d here that we got is equals to 51. And then surprising enough, if we say T25 plus T26, it gives us the same expression. It gives us the same expression, right? So for the fact that we have the same expression, that means that 2a plus 49d is also equals to 51, which means in other words, T25 plus T26 is equals to 51. That's how you conclude it. Nice. So very interesting question right there. Very interesting question. Okay, so where do we get our marks, sir? To substitute into the formula. So substituting here into the formula, it's a mark. And then having to expand the T25 and T26 is a mark, right? So I've expanded right here when I added them together. And then having to find the expression for T25 and T26, that's also another mark, right? So yes, you might cry and say it's unfair because there are a lot of steps that are unmarked there. Then yeah, that's how it is. So, okay, 14 marks in the bag, just like that. Very nice, very nice. So at this moment, you are now picking up the momentum. You are now picking up the momentum. So every time you are solving your questions, guys, every time you are dealing with this, it's all about conserving your energy, guys. It's all about having to conserve your energy. So make sure that you always keep a positive mind in solving all of this. Now, they say for which values of x will the sum to infinity. Remember, once you have that, that means sum to infinity. For which values of x will the sum to infinity exist? Now, obviously, this will exist here they're basically asking you, we know the sum to infinities are mostly basically a convergent series. Convergent series. So we are trying to calculate the value of R here, for which this will be a convergent series. So basically, I mean the value of X for which this will be a convergent series, right? Because sum to infinities are usually convergent series. Then, okay, so obviously the first thing that you have to do is at least have 3 terms, right, for this. At least line up 3 terms. So your case starting from 1. So that means the first term T1 will be 4x minus 1 to the exponent of 1, which I do not need to indicate, or maybe let me indicate. Then plus k will now be 2, 4x minus 1, and then to the exponent of 2. And then the third one will be 4x minus 1 to the exponent of 3. Right. So now you have your series like that, term number 1, term 2, term number 3. But then remember, for a convergent series, your R must be something between -1 to +1. So first, let's get the value of R. We know to find R, the ratio, common ratio, is T2 divided by T1. So if we can take T2 here, 4x minus 1, and then square over 4x minus 1, and then to the exponent of 1, we know that obviously this one will cancel out with that. So if we expand this, the square here means that we have to expand this twice. So that's 4x minus 1. And then obviously we have a cancellation of this and that, and then we are only left with our R being what? Our R will just be 4x minus 1, right? But then we are not done. Remember, we are trying to calculate the values of X, for which this will be a convergent series. So in order for us to have a convergent series, we must make sure that our R value is in between 1 and +1. So there we go. Now, if we take this and transpose it over to that side, that's -1 plus 1. And then here we have 4x. If we take this and transpose it over, we have 1 plus 1. Right. So it's just a matter of taking that constant value, transpose it over to this side, and transpose it over to that side. And in both situations, it changes the sign. So it was a negative, it becomes a positive. It was a negative, it becomes a positive. So, but the -1 plus 1 will be 0. And then here we have 4x. 1 plus 1 will be 2. So if we want to find the value of X, obviously we need to divide throughout by 4. Right? So this is going to be 0 still, X, and then here 2 divided by 4, we have 1 over 2, right? So there we go, right? And then also, we must make a restriction. There must be a restriction because our R here cannot be equal to 0. Remember, R should not be equal to 1 or 0 at any given point, right? So we have to eliminate the values that would make this to be equal to 0 or 1. Okay, so obviously here, if we are to have 1 over 4, this would be 1 minus 1. So R should not be equal to 0. So we must come over here and say our X should not be equal to 1 over 4. Because check, if we say 4, 1 over 4, and then minus 1. So basically, to find that value, that it's ROA, it's 1 over 4, you can just simply say, let's say 4x minus 1 is equal to 0. So this would be 4x is equals to 1, and then divide both sides by 4, your x is equals to 1 over 4. But then if your x is equals to 1 over 4, that means R is equal to 0, but R should not be equal to 0. So that means we must come over here and have a restriction that says X should not be equals to 1 over 4. Because if it becomes 1 over 4, that means we no longer have that convergent series. Matter of fact, we don't even have a series, right? We don't have the geometric series. So, okay, so that's the most important part there that you needed to find. So, okay, mark for finding the value of R. There is a mark for having the condition, right? So condition, they're talking about this one, where you substitute to say that your R should be in between -1 to 1. So that condition ends you a mark. And then having to do what? Having to find the answer there. And then also the restriction here. The restriction gives you a mark. So if you didn't have the restriction, that means you are only going to get 3/4, right? So you always need to remember restriction. Your R should never be a negative. I mean, should never be equal to 0. Okay, so determine. So 3.2 says determine the figure below. The figure below shows a pattern of 5 circles touching externally, as we can see. Centers lies on a straight line of length L unit. The radii of these circles form a geometric pattern where the radius of the smallest circle is 3 units and that of the fifth largest circle is 48 units. So this is the last one here. 3.2.1, determine the common ratio of the geometric pattern formed by the radii. Right? By what? By the radii. So by the radii. So we are being told here that the radius of the smallest circle is 3 units and the radius of the largest circle is 48 units. So if we want the radii or the common ratio, it's just a matter of saying 3.2.1. It's just a matter of using the Tn formula, ARn minus 1, where we're going to take our Tn as the last term. And then we know A is the first term, right? Then it's just basically that n will be 5 because as we can see, we have 5 circles right there. And then they did say that the fifth largest circle is 48 units. So Tn is 48. And then our A here, our first term, the radii of the smallest circle is 3, right? So 3, and then we are looking for this R here. And then to the exponent of 5, to the exponent of 5 minus 1. And then this is 48 is equals to 3, R to the exponent of 4, 5 minus 1. Then we can divide both sides by 3. Right, now what is 48 divided by 3? That's 16. And then we have R to the exponent of 4. Then at this point, we can then square both sides. Then obviously our radius here should be a positive value. So it should be positive what? 2. Right. So yes, there we go. There we go. So 3 marks just like that. Okay, so let's see, where were the marks? Substituting into the formula, both your Tn value and your A value, it's a mark. And then having to simplify here, it's a mark. So simplify can be anything up to that point, and then having the answer there. So 3 marks just like that. Now they say determine the value of L. Note that L is made out of the diameters of the circles, right? It's made out of the diameters, not only the radii. So diameter is twice the radius. So if you can add all the diameters of these 5 circles, then you get the value of R, the value of L. So, okay, for that, we are going to say 3.2.2. Now, note that if the radius here is 3 units, that means the diameter is 6, right? So it's just like everything here that we have multiplied by 2. Now, you can decide to do it manually, or you can use a formula, right? I don't think they would penalize you for doing it manually, or they just wanted no. I think, yes, there's also an option that provides for you doing manually. So which I feel would be the most quickest approach here, because you just have 5 circles. So you know that the diameter of this one would be 6, followed by the diameter of this one here has to be 2 times that. So it's 12, followed by the diameter of the other one, because note that your common ratio is 2. So to get the next term, you just need to multiply it by 2. And then this will be 24, followed by what? By 48, followed by what? 96. And then you can just add all those ones up. So this will give you what? 186. 186 units. So just simple like that, just straightforward. Or if you are fond of the formula, you can then use the formula for Sn, right? Because this is a geometric pattern. So you will just say Sn is equals to a bracket r to the exponent of n minus 1, and then r minus 1. Then you have your restriction by the side. Your r should not be equals to 1. And then your a value meaning the first circle, its diameter will be equals to what? Its diameter will be equal to 6. Remember, we are now focused on the diameters. Then your radii is still equals to 2, and then to the exponent of 5 circles, and then like that. So this is 2 minus 1, which if you punch all of that into your calculator, you're still going to get 186, right? So that's your L, right? So you take your L like that. Then, or you can use the radii, but if you use the radii, you need to be aware that you need to then multiply. So if you just use the radii, this is still that. And then we have a 2 minus 1 here. So which you are going to get what? You are going to get a 93, right? But then you need to then remember that you use the radii, and then here we have diameters. So you need to then multiply it by 2 so that you get the value of L, which is 186 as well. So 186 units. So either way, you could have used any of those options here. You could have got the answer there. So if you used obviously your equation here, that means substitution into the formula and then simplifying, and then the value of L here. If you use this one, they're just going to give you 2 marks for adding here and then a mark for that. Okay, so nice. Then 3.2.3, they say now the pattern is extended by 5 more circles to 10 circles. So that means they add 5 more circles, still following the same the same approach here, still following the same method of expanding this by a scale factor of 2. So that means the 6th one is twice this, and then the 7th one all the way like that up until the 10th circle, right? So, okay, now that means they say calculate in terms of pi, the total area of the 10 circles, right? Now, we do know that the formula to calculate the area is what? Area of any circle is calculated by the formula. Area is pi r square, right? So that means if we wanted the area of the first circle here, this would be what? This would be pi and then 3 square. And then followed by what? The second one would be pi 6 square. And then the third one would be pi. Now you can do this manually up until you get to the 10th cycle, but then that would be time consuming, of course, and then 12 and then square. So you already know the formula. So all the way to 10 terms. So to 10th term, right? So this is how the pattern will go. So that's how you calculate the area. Now they want the what? The pattern is extended. Calculate in terms of pi, the total area. Now the total area is what? The sum, right? So they want the sum of the areas there. Now you can use the formula 3.2.3. That's Sn is equals to n. Look at me using the wrong one. So this is a bracket r to the exponent of n minus 1 over r minus 1, right? Now, what is your a value? Your a value is going to be this, right? Pi 3 square, which obviously 3 square will be what? 9. So 9 pi. Remember, they said in terms of pi. So that means in everything that you do, you must keep that pi there, right? The pi must be kept there. So 9 pi. So this is what? S10, sum of 10 circles. And then what's your r? To find your r, it's just simply r is equals to what? 6 square is going to give us what? 36. So 36 pi divided by what? By 9 pi. So pi and pi cancels out. Then remember, I still have the pi there. So 36 divided by 9, our r will be 4, right? So that's just a common ratio. So 4 to the exponent of 10 minus 1, and then over what? 4 minus 1. So that means now we are going to have what? S10 is equals to 9 pi over what? 4 to the exponent of 10 minus 1. This is supposed to give us something like 1,048,575. What a big number. And then here divided by what? Divided by 4 minus 1 is 3. So we can say 9 divided by 3. This will give us what? 3, right? So we have 3 pi multiplied by that 1,048,575, right? So that means our S10 now, we need to take the 3 multiplied by that, which we are going to get 3,145,725. And then what? Pi. So that's writing in terms of pi, meaning that we should not put the pi in a calculator and get the answer there. We should just leave it like that, pi, right? All this talking about pi is making me hungry. Then, okay. Area of a circle. So it's a mark for having to express that in terms of the area of a circle. It's a mark having to find the value of r. And then having to substitute all of that into the equation, it's a mark. And having to get our answer in terms of pi, it's a mark. So 4 marks just like that, right? So know where your marks are, know where your marks are. So it is best in maths to just show all the calculations there. You must always show the calculations. So you see now, you are given a mark for this. If you did not show how you got r, you might face a problem. Okay, so we move. So done with that, we are now on question 4, which is based off your functions, the hyperbola function to be more specific. Then the lines y is equals to x plus 1 and y is equals to negative x plus 3 are the axes of symmetry of the function. G of x is equals to negative 4 over x plus p plus q. They say those are the what? Axes of symmetry. So we know there are 2 axes of symmetry in a hyperbola function. We have the one with the positive gradient and the other one with the negative gradient. Now they say show that p is equals to negative 1 and q is equals to positive 2, right? So how are we going to show that? We already know this. So what we can do is we know that the axis of symmetry will intersect, and where they intersect where we have the what you call, they intersect where we have the asymptotes, right? So they intersect where we have the asymptote. So in order to calculate that, this is what we're going to do. We can equate these ones here because they will have a point of intersection. So for 4.1, just going to say, let's capitalize on the fact that these ones have a point of intersection. So it's equals to negative x plus 3. So this is going to be what? X and then plus x. So I'm just transposing here. So where there's x, all the x's will be on one side, and then all the constant values will be on one side. X plus x, that's 2x, and then 3 minus 1, that's 2. Then divide by 2, divide by 2. So x is equals to what? 1. Right? Now, if x is equals to 1, I already know how I deal with the p-value here. If I want to find the value of p, remember this x here speaks to this x over here. But then whenever we are trying to find the values for the asymptote, this is what we normally do. We just take the x plus p and then equate it to what? To 0. So now remember the x is 1. So how do we find the value of p? It's 1 plus p, and then p will be equals to negative 1. Voila. So that one is down. Then to find the value of q, it's just a matter of substituting the x value to either one of these equations here. So if we can say y is equals to 1 plus 1, then y will be equals to 2, right? And just like that, we do know that if we are to find the value of the other asymptote, which is the horizontal asymptote, we normally just say y is equals to q, right? So the y value is usually just equal to the horizontal asymptote, meaning in other words, we can just simply say whatever that we got for y is exactly the same for q. So q is equals to 2. Then voila, you have it like that. So, okay, now there is a mark for having to equate the two expressions. There is a mark for finding the x value. There is a mark for finding the y value. And obviously, you know how you then should interpret that, right? So your p value should be negative, and then your q value should just stay like that. So always note that the change in sign happens if we have a plus here, right? If we have a plus here, we obviously, if that is a positive, then our p should be expressed as negative. But if we have a minus, then we know that the p value should have been just positive, right? So there's always that interchange in signs. Okay, so 3 marks just like that. Now 4.2 for just 2 marks, it's saying calculate the x-intercept of G. X-intercept. Now the x-intercept, we know that whenever we are dealing with the x-intercept, we make y0. So x-intercept, you make y0. Now these are the kind of questions, if you did not get these ones, you can still use those answers there and substitute them there, right? So you can forfeit the 3 marks, but then you can still continue getting the other answers, right? So just because you couldn't get this one should not restrict you from getting all these other marks. So always in your mind, think of collecting marks, right? So this is it. To calculate that, we are just going to say where g of x is, I'm going to put 0, then negative 4 over x. Remember the p-value, now I have it. So it's negative 1 there. And then this is plus 2. Then I'm just going to calculate. So the first thing that you want to do, don't do this. Don't cross multiply first. You have a value here. So the first step is to take this over to this side. So that's negative 2 is equals to negative 4 over x minus 1. At this point now you can cross multiply. If you just write this as negative 2 over 1, then cross multiplying here will give you negative 2 bracket x minus 1 is equals to negative 4. Now it's up to you if you want to fast forward, or you can just start by dividing by this negative 2 both sides, right? I normally prefer my maths to be a little bit clean, so I just do that. So x minus 1 is equals to negative 4 divided by negative 2. That's positive 2. So x will be equals to what? Positive 3. Right. And that right there is my x-intercept. So obviously, the mark that you are going to get here is just understanding that your y should be equal to 0. That's the first mark. And then having to calculate your x-intercept. 3. So 2 marks for that. Now, 4.3 is now saying, sketch the graph of G in your answer book. We obviously don't have an answer book here, so I'm just going to sketch here. So, okay, so you do know that you have to start with your Cartesian plane, and then you have to be mindful. Also, you need to be mindful of what you have as your A value, because your A value determines the shape of the graph, right? We do know that if it's negative, just like this one, then our graph should occupy the second and the fourth quadrant. So very important for you to note that. Okay, so let's now have our thingy. So obviously the first thing I always say every time you want to draw this, start with the asymptotes, because your asymptotes determine the new Cartesian plane, right? So the new Cartesian plane would have to be represented by what you get as your asymptote, right? So the vertical asymptote is P, which is negative 1. So it should be drawn somewhere here. Remember, it's a sketch. You don't have to be precisely correct with the scale, but then again, your scale should be a bit convincing. So those are your asymptotes, meaning right now, this is just the first quadrant, second quadrant, third quadrant, and fourth quadrant, right? So your asymptote, it's more like they determine the new Cartesian plane. So that's what I mean by that. And then obviously at this point, you need your intercepts, right? So you did calculate one of the intercept, which was the x-intercept. You got that it was a positive 3, right? So it's just going to intersect somewhere there. And then voila, just a smooth curve, guys. Try. I know a lot of you, you fail to draw curves, but then just try, guys. Just try. So just a smooth looking curve. Whoa. Trouble in paradise. Let's see. This was x minus 1. So that means our asymptote was actually supposed to be positive. Yes, let me fix that right there quickly. So yeah, the asymptote was supposed to be right here. Okay, busted that one quickly because now I could see that my shape is not shaping now. Shape was not shaping. Okay, so there we go. There we go. There we go. Fix that. Then the 3 will be somewhere here. And then obviously with the asymptote there, so it's not touching that one. Right. So note that the origin in my case is the red one. Right. The red one is the origin. And then this is the first, second, third, and fourth quadrant. Yes, now it's shaping. Then, okay, let's now find the y-intercept. So we have y is equals to negative 4 over x minus 1, and then plus 2. So we make x equal to 0. Then y is equals to negative 4, put 0 here, 1, plus 2. So this is going to give us what? Negative 4 divided by negative 1 is 4, plus 2, and then this is 6, right? So we must have an intercept somewhere here at 6. So let's say, arguably, 6 would be somewhere there. And then like that. Yes. So I'm trying, guys, to have a smooth curve. There we go. Right. And then we can label our asymptotes here. So its x is equals to 1. And then also this one here, y is equals to 2. Okay, nice. So this is the intercept that we were talking about for this one, right? The one that we used to find the value of P and Q. This is the point of intersection that I'm talking about, where your asymptote will intersect. And obviously, this is where even your axis of symmetry intersect, because your axis of symmetry, they're supposed to go something like this, right? So if in your axis of symmetry, the one with the positive gradient and the one with the positive and negative gradient intersect at that point. But obviously, you are not supposed to draw that. So I was just trying to show you there. Okay, so 4 marks, what do they mark? They mark, so also it's important for you to know where the marks are. They mark the horizontal asymptote, correct? They mark the vertical asymptote, correct? They mark the y-intercept, because obviously the y-intercept, you had to calculate it on your own. So they mark that. And also the shape, the fact that you have it on the second and the fourth quadrant, they mark that. So the fourth mark is for the shape. Is the shape correct? Okay, then 4.4, for which values of x is g of x greater than 0? Now, obviously, you win over these questions here by knowing how to interpret, right? So you must know what they mean by that. G of x greater than 0 in layman's term means that look for where the graph of G is above the x-axis. So that's what it means. Look for where the graph of G is above the x-axis. Now, obviously, what we have drawn here is the graph of G. Where is it above the x-axis? We want it to be above this red horizontal line, right? So we're just simply going to take our box here and then say we can see it is above the x-axis at that point. Remember, what was the point there? Also, we must label. So this is x, this is 6. The y-intercept is 6 here. And then the x-intercept is 3 here. Yes. So this is 3. This is from 3 going all the way to that direction. So from 3 going all the way to that direction, we can see it's above the x-axis. Again, if we can check here, this will be above this whole arm here, or this whole curve here will be above the x-axis, right? So we can say in between this point here. So all the way from this point going to that direction, right? To that direction. So all those points there. And then How do we then express that for 2 marks? We are going to say, remember, this is infinite, right? This is all the way from negative infinite. So we can say, starting from this point, it's up to you how you write it, guys. You can say starting from 1 all the way there, which 1 should not be inclusive, because as we can see right here, 1 is an asymptote. It will never touch that point. So you can say for all the values where x is less than 1. So when x is less than positive 1, meaning from here going all the way to the left, as you can even see with the indication here. So x less than 1 going in that direction, or when x is greater than what? Than 3. So from here start going all the way like that. 3 cannot be included because at 3 it's equal to 0. It's directly at the x-axis. It's not above, it's not below. It's just at the x-axis, but we are looking for where it is above. Remember, they did not say greater than or equal to. They just said greater than, so where it is above. So for the points where it's starting from 3 all the way that, so from a value that is greater than 3. So there we go. Or others, the way they would be indicating this is to say when x is an element from negative infinity all the way to positive 1. Or again, when x is an element from 3 all the way to positive infinity. Right. So it's just basically up to you which notation you prefer. But then that's how you were supposed to tackle that question right there. Okay, so nice. So we are heating up. Now on question 4. So at this time, you have already collected a decent amount of marks, right? If you have tried to find as many questions as possible or get as many answers as possible. And then, okay, now we have this question 5 here, which is the parabola function, says the sketch below shows the graph of f of x is equals to negative square root x minus 2 and then square plus 9, which obviously we can say that it is written in the form of what? In the turning point form, right? The turning point form. And g of x is equals to b to the exponent of x. So this is a logarithmic function. Then d is the turning point of f, and a point of intersection between f and g. So d is both a turning point and a point of intersection. B is the y-intercept and a and c the x-intercept of f. So a here and c are the x-intercept, and then b happens to be the y-intercept. Okay. So we can see all that. Then let's now check. Determine the length of AC. Now, obviously, to determine the length of AC, would have to know the coordinates of A and C, right? So how will we get the coordinates of A and C? From up here, we can see that we have the equation, right? That one, right? So we want to determine AC, the length of AC. Now, this is a horizontal line. We know to determine the length of a horizontal line, it's always x coordinate on the right minus x coordinate on the left. There's no need for you to use the distance formula here. On a horizontal line, always note this. There is no need for you to use a distance formula. On a horizontal line, it's this. Then on a vertical line, it would be the y at the top minus the y at the bottom, right? So that's how you'd get the distance for the vertical line, right? So note that, because some of you find yourself using the distance formula when it's just straightforward like that. Okay, so obviously we need these ones. And they said, according to the statement, they said those are the x-intercepts, right? Those are the x-intercept. We know with an x-intercept, we always have to make y equal to 0. So f of x is y. So that means we can take this expression here and equate it to 0, right? And then we obviously want to start solving there. So again, it's up to you how you do your maths. Others might choose to expand it. Others might just choose to transpose that over to that other side. It's all up to you. So let's go with the one that we are used to. We are used to expanding. And then this will be x squared minus 4x and then plus 4, right? And then plus 9 equal to 0. So this is negative x squared. If we multiply inside by the negative, plus 4x and then minus 4, and then plus 9 is equals to 0. So we now have negative x squared and then plus 4x, then negative 4 plus 9. This will give us what? Positive 5 equal to 0. Now, we always try to have a positive a value here, so we can divide throughout by negative 1. So this is going to be positive x squared. Positive times negative is negative. Positive times negative, negative as well. And then at this point, you either factorize or you use the quadratic equation. So if you factorize, it's going to be x minus 5 and then x plus 1, which will give you the negative 5 over here and the negative 4 right here. So your x is going to be 5, or your x is equal to negative 1. Now, obviously, knowing your knowledge, having a knowledge of your Cartesian plane, you know that your a here must be the negative 1, and then your c here must be the positive 5. So therefore, to find the length of AC, you're simply going to say the x coordinate on the right, 5, minus the x coordinate on the left, which is negative 1. So 5 minus negative 1, that's 5 plus 1, which is going to give you 6 units, right? Which makes sense because if you have 0 here, from here to here, it's only 1 unit. And then from here to here, it's 5 units. So the 1 unit and the 5 unit gives you 6 units. So right. So you have your 4 marks like that. Then how are the marks distributed here? For letting y be 0, that's a mark. For having to solve this up until you get to the standard form, it's a mark. And then for your x values, it's a mark, right? So both x values are correct, it's a mark. And then having to find your answer here has 6 units, it's a mark. Then 4 marks, just like that. Then determine the value of b, right? So the value of b right there. Remember, to find the value of b, we would need to say, so this is y is equals to, now we always know that with this one here, so let's see that one. So for the value of b, are we given the coordinates? Yes, we have the coordinates of d. Remember, D is the turning point, and I did mention that this one here is expressed in turning point form. So this is f of x is equals to negative x. So this is expressed in the form of this. Let me write it. A x minus p and then square plus q, where we know that the turning point is usually represented by the value of p and the value of q. So what you are seeing here, these are the coordinates of D, right? So that means this translates to D being what? Being positive 2:9, which the positive 2:9 also forms part of the equation of G. So we can use the coordinates here of D to find the value of B. G of x, remember, is y, and then x is x. Then that means using the coordinates of D, which is 2:9, we can say g of x is equals to b to the exponent of x. Where there's g of x, we substitute 9, and then where there's x, we substitute 2, right? Then it's up to you whether you just decide to square this or maybe write 9 in terms of the exponent. So 3 to the exponent of 2 and then b to the exponent of 2. Now, since the bases have the same exponents, we know that we can just equate the bases. So b is equals to 3, right? So just like that. And then, so that was what? 2 marks. So to substitute into the equation, right here into the equation, it's a mark. And then having to find the value of b, it's a mark. Then determine the value of x for which g of x is greater or equal to 9. So where the value of g, where the graph of g is equals to 9 or greater than 9, right? The value of g. Remember, at this point here, d, it is exactly equal to 9, right? So can just even use the graph there, right? So remember, what was the x coordinate at that point? Found that it was 2, right? So that means for all the values that are greater than 2, all the values that will be greater than 2, what will happen to that? What will happen to the graph? The graph will be greater than positive 9. So that one did not even require any calculation. You just say when x is greater than what? When x is greater than or equal to 2, because at 2, it is exactly equal to 9. But then for all the values that will be greater than 2, your graph of g will now start producing y values that are greater than what? Than 9, as you can see there, right? But then again, if you wanted to calculate, you would just say you already have your b there is 3, so you have 3 to the exponent of x greater or equal to 9. Then this would be 3 to the exponent of x greater or equal to 3 to the exponent of 2. The bases are the same, so that means you equate the exponents. There you go. So it's up to you whether you would have just used the graph to see that or just do a calculation. So I know most of you will just go with the calculation. Okay, so that was 1 mark. And then write down the equation of h if h of x is equals to fx plus 2 minus 9, right? Now also again, this is a question on what? On transformation, right? This is a question on transformation. This is what you need to understand when it comes to transformation questions. So our f of x is obviously, which graph here? It is the parabola graph. Now what does this mean? X plus 2 means that whenever you have x plus p, this means this is shifted p units to the left. So remember, if we have a plus, it's shifted to the left. But then right here, if you have q being something, negative q, for example, this means it's a shift q units downward, right? So these are your translation, right? So now they're saying they want the equation of h if h of x is the equation that will be obtained if you shift the graph of f 2 units to the left and then also what? 9 units downward. Now, in order for us to be able to answer that, we need to first write the original equation. So it's f of x is equals to negative x minus 2 and then a square and then plus 9, right? So note that we are supposed to do what? We are supposed to shift this 2 units to the left. We are supposed to shift this 2 units to the left. That means now we must come over here and say we have this negative, we have this minus 2 here. But then we are trying to shift it to the left. Remember, when we shift to the left, what must we do? We must add that 2, right? So it's more like this is what we do. So I want you to understand this from this point. Take this as if where there is x, I will have to substitute this expression. Now, where there is x, I will have to substitute by x plus 2. So where there is x, I substitute by x plus 2. But then I still keep that minus 2 over there, right? You see that? So where there is x, I just replace by the x plus 2 here. Then still say minus 2. And then this is what? Plus 9. But then what must I do? I must then shift it 9 units downward. So what do I do to this 9? I subtract 9 here. So that means this is f of x is equals to what? Negative. Now the negative 2 minus 2 will give us what? 0. So I'm left with x here and then square. What will happen here? What is 9 minus 9? That's 0 as well. So that means f of x now is just equal to what? Not f of x, g of x. Remember, here this is where h of x, I was expressing h of x. Yes. So this one, remember, when I shift it, it now changes to h of x. So h of x means now is equals to what? Negative x squared, right? So what they did here is they shifted this 2 units to the left first. So it's more like taking this graph over and then it becomes like this. That means the turning point now will be here, right? So that means the turning point will be here. So that's the first thing that they did. They shifted it 2 units to the left. After shifting it 2 units to the left, what did they do? They then shifted it 9 units downward. You see? 9 units downward. That's how we ended up having this equation. So we know from grade 10 that all the equations that used to be like this, if it was concave down like this, it used to be negative x squared. And then if it was concave down like that, it used to be positive x squared. So this is what the original graph looked like, the mother graph, with turning points at 0 is to 0. Right. So they shifted that to create the mother graph, the inverse of the reflection along the x-axis of the mother graph. So first shifted 2 units to the left and then 9 units downward. And that's how we ended up with that. And then that's the equation right there. Now they say, how can the domain of H be restricted so that the inverse of H will be a function, right? So that it will be a function. Right, now there are 2 ways in which you can restrict a domain. You can either restrict the domain to be x, so for 5.1.5, so that one. Okay, before we get to that one, let's discuss the marks for this one here. How many marks was it? 2 marks. So it was just going to be for the substitution of the x plus 2 where there is x, and then also for the answer there, right? So there we go. Okay, 5.1.5. How can the domain be restricted? Now we know about the restriction of the domain. The domain can either be restricted by saying x must be less than or equal to 0, or can be restricted by saying x must be greater or equal to 0. So you can either just consider the positive x values, which are going to be all the x values this side, or you can just consider the x values that are negative, which are going to be all these ones. So it's all about having to cut one part, right, so that it passed the vertical line test. So, but then obviously they're talking about the inverse. The inverse of that is the one that will look like something like this. Something like this, yes. Okay, so let's now move. Show algebraically. So they say show algebraically that g x plus 1 over 2 is the same as that. Interesting question. So let's see. So the equation of g, remember, g of x was equals to 3 to the exponent of x, right? Now again, remember what this means. It means where there is x, I now have to replace by that. So 5.1.6. So I'm now going to have 3 to the exponent of x plus 1 over 2, like that. And then is equals to what? So we basically want to prove that the left-hand side will be equals to what? To the right-hand side. So what is root 3? So root 3 g of x is the same as having root 3 times 3 to the exponent of x, right? Okay, let's see. So when we solve this from the left-hand side, we know from our laws of exponent that this, according to a to the exponent of m plus n, which says that if we have this, it can be expressed as all the exponents can be expressed to the same base, which will end up giving us a to the exponent of m and then a to the exponent of n. This is a law of exponents. So we're just going to use that law of exponent here on this one to say that this can also be expressed as 3 to the exponent of x and 3 to the exponent of 1 over 2. But we know that 3 to the exponent of 1 over 2 can be written as what? Can be written as root of 3, right? Again, it comes from a law of exponent. It says if I have a to the exponent of 1 over 2, this can be expressed as square root of a. And then if I have a to the exponent of 1 over 3, this can be expressed as cube root of a. Those are laws of surds and exponents. And then look now, if I just write this in that order, this will be root 3, and then to the exponent of 3, root 3 times 3 to the exponent of x, which basically is the same as saying root 3. And then remember, what was g of x? G of x is 3 to the exponent of x. So this is similar to just saying root 3 times g of x, which, yes, voila, it means that the left-hand side is equals to the right-hand side. So we have proven that it looks exactly the same as that. So there we go, 2 marks. Then, so this was just going to be a mark for substitution, like this. And then it was going to be a mark for a use of the exponential laws, right? So they just wanted to check if you know your laws of exponents. Wow. Wow. Okay, we move. We still have another one. Okay, so question 5 is still continuing. Given f of x is equals to ax squared plus bx plus c and g of x is equals to mx plus c. If given that f of x times g of x is less than 0 for all values of x when x is greater than -6 but less than -3, or x greater than 2, determine the value of a in terms of m. Show all calculations. Okay, so yes. So now they're saying f of x times g of x is less than 0. So what does it mean? Number one, we have to interpret this. F of x times g of x less than 0 means that we are looking for where this one will be above the x-axis, but this one is below the x-axis. Or this one will be below the x-axis, and this one will be above the x-axis. So where one graph is below x-axis and the other above the x-axis. So you can't answer these questions unless you can interpret that. Okay, so where are those points? Where are the points where we see one graph is above and the other is below? So we can see that we have points here. So note how smart we'll be solving this. So if we can check here. Check here. Whoa. Too far. Okay. A little bit. Yeah. I'm not getting this. Okay, so here. Yes, yes. Right. I want you to have a look at that point there. You can see that this one here, below the x-axis, that one above the x-axis, right? That's one point. They said this happens between when x is greater than -6 and x is less than -3, and also where x is greater than 2. Now we can see that here we are on the positive x-axis, and then x greater than 2 would be somewhere here. So that means this point here would have to be what? 2. Interesting. Then let's look at the other part whereby we have that happening, where one graph is above and the other is below the x-axis, in between these points here, all the way up until here. So in between this point, let's see. This one above the x-axis, and then this one here below the x-axis. But once we cross over this part, they will now be both below the x-axis. And once we cross over here, they are both above the x-axis all the way up until this point. So that means this would have to be the -6 that they're talking about. And then this would have to be the -3 that they're talking about. Interesting. So now you can see that I now have the x-intercept. So which means I can now use that to find the value of a. How am I going to find the value of a? By using what we call as the root form method, right? More like I'm trying to get the equation. So this is going to be what? Y is equals to a bracket x minus x1, x minus x2. Now I have my intercept, right? And then I am going to say this is y is equals to a. And then substitute my roots. This is x. This is -3. So negative and negative, that's +3. And then here I have my x. And then substitute the root. That's going to be -2 there. And then this is going to be y is equals to a. If I can just deal with what's inside the brackets here, that's x times x is x squared. X times -2 is -2x, and then this multiplied by that, that's +3x, and then this multiplied by that, that's -6. So I'm going to have y is equals to a, x squared, this and that will give me positive x, and then -6, right? And then, okay, now, if I multiply inside, this is going to be a times x is ax squared, and then a times that, it's ax, and then I have -6a. So, okay, there's nothing more that I can do now. Can just say this is equation 1. Okay, so what must I do now? At this point, I can use the fact that for the straight line, I only have this, right? I only have that. So I can now say, let me just say y is equals to mx plus c for this one, right? And then as you can see, we have the coordinates for this one. It's supposed to be -6 is to 0. So where there is y, I put 0. And then let me try to get the gradient. So remember, we are trying to determine this in the value of a in terms of m. So this is just m here, and then -6, and then plus c, right? So which is this. So, but then c here, according to this, remember, this one here should always indicate the y-intercept. According to ax squared plus bx plus c, the c here, which is the constant value, always represents the what? The y-intercept. So where they say, I can substitute by what? By -6a. So this is going to be 0 is equals to m times -6, that's -6m, and then -6a. Pretty interesting. And then now I can then take, remember, I'm trying to find the value of a in terms of m. So let me just take the -6a over to this side. So this is 6a is equals to -6m. Then I can just divide both sides by 6. And then my a will be equals to -m. Right. Right. So that's it. That's it. That's how we were supposed to calculate that. So, okay, there is a mark for having to substitute into the formula your intercepts or your roots. And then there's a mark for having to simplify to that. And then there's a formula for having to substitute into the formula on this one. And then there's a mark for having to substitute in the value of c. So having to see that you can substitute the value of c as that. Right, so substitution here, having to see that you can substitute that value of c as the 6a there from here. So it's a mark. And then having to now find the value of a in terms of m, which is -m. So there was 5 marks. 5 marks. So that's how you were supposed to approach this question here. So it was a pretty interesting question. Yeah, kind of challenging. But then once you get the drill, then you should be able to solve this kind of questions. Yes, so yeah, we are busy gaining momentum as we solve these questions here. Okay. Okay, so question 6 says the sketch below shows the graph of g of x is equals to 2 to the exponent of x plus q. And f of x is equals to log base 1 over 2x. Graph F and the asymptote of G intersected B is 1 is to 2 is 1 over 2 is to Q, right? Okay, so we have 6.1 saying write down the coordinates of A, right? So to write the coordinates of A, we know that A there is an x-intercept. So we already know that the coordinates here will be 0 is to 1. It's just saying write down, but then if you want to calculate, it's just a matter of saying log base 1 over 2 to the exponent of x, and then you make your y0 here. This is log base 1 over 2x, and then obviously this here carries this one as an exponent, and then we are left with x here. So any number expressed to the exponent of 0 is equals to 1. So therefore our coordinates for A here become 1 is to 0, right? So 1 is to 0. Okay, so that's it. So there will only just be a mark for having to write 1 is to 0 there. Okay, so now we move. The next question is now saying, determine the domain of F, right? Now, what is the domain of F? We know that here, since we have an asymptote here at what? We have the asymptote at x is equals to 0. So that means the domain of F here should be what? All the values, so from that are greater than 0. So it should be x greater than 0, right? So your coordinates for A, 1 is to 0, and then here the domain is x greater than 0, right? So which is the opposite of an exponential graph. An exponential graph, usually the original mother graph is you find that the domain is x element of real numbers, and the range is the one that is y greater than 0. But then here you find that the range is y element of real numbers, but the domain is x greater than 0. So you can even find that on the video that I did on exponential and logarithmic functions. Now, 6.3 says determine the equation of the inverse in the form of y is equals to. So we have a g of x or f of x is equals to log base 1 over 2 to the exponent of what? Of x, right? If we want to determine the inverse, which will now be the exponential function, just gonna do this and then take number 1, we must say let y be equals to x. So where we will then interchange this, right? So where there is y, we put x, and then where there is x, we put y. So that means x is equals to log base 1 over 2 and then y here. Then what we simply do is just take this one over to lift that one up as an exponent and then equal to y. So y will be equals to 1 over 2 to the exponent of x. And that's just that, right? So that's your answer there. So you're going to get a mark for having to swap the x and y values here. And then you're going to get a mark for the answer. So 2 marks. Okay, so we then have sketch the graph of the inverse. Indicate on your graph the intercepts as the intercept with the axis and the coordinates of the other point on the graph. Okay, so let's check that one out. So we are to sketch the graph of the inverse of f. Inverse of f. So let's then sketch. So the sketch for that one would look like this. We do know that obviously we must have this right here being the intercept, and then it's gonna go like that. It's gonna go like that. So a little bit like this. And then obviously the asymptote right now should be the y is equals to 0. So it will approach this x-axis but never touch it. So that's the asymptote there, y is equals to 0. And then this point here, we must indicate that the point over here will be what? 0 is to 1. And then also this point over here should be what? Because here we would have a 1 over 2. If we are to substitute here, if we are to substitute on this one, log base 1 over 2, and then we have 1 over 2 here. This would give us 1, right? So that means the inverse of that would have to be found here, somewhere here, whereby now we have to have what? 1 is to half. So whereby now we have to have 1 is to half. So somewhere right there. Maybe somewhere here. Right. Okay, so that's how we would indicate that. So it's the shape is the y-intercept. And then let's say maybe we've shown a point right here, which is supposed to be, in our case, 1 is to 1 over 2. So there would be a mark for that. So there's a mark for the shape, there's a mark for showing the y-intercept, and there's a mark for showing just one other point, right? Usually when you show the one other point, you just inverse the coordinates that you got from the other original graph, right? So 3 marks like that. Okay, now what are they saying? Determine the equation of the asymptote of G. Determine the equation of the asymptote of G. So what is the equation of the asymptote there? Now we can see that we are given the equation there of G of X. So what we can do is we say G of X. So what question is this one? 6.5. We'll say G of X is equals to 2 to the exponent of X plus Q. But then as we can see, we are already given the coordinates there for that one. So, okay, we can just simply say to find that the asymptote is in line with what we have here on the graph of F. So we can just simply use that, okay? Almost got me confused there. Or we can just use this. So f of x is equals to, so that's basically the same thing that I did for here. F of x is equals to log base 1 over 2x. And then this is just log, yes. So it's quite the same thing. So I can just say, this is my 6.5 right here. This is my 6.5. So I was using it to find the other point. And then basically I just got that one as well. So this is my 6.5. And then having to find my y as q, I know that the asymptote here has an equation of y is equals to q, right? So that means, in other words, my asymptote q will be equals to what? To 1. So as an equation, you need to say y is equals to 1. As an equation, you need to say y is equals to 1. Because y is equals to q. Okay, so that's it. Describe in words the transformation of G to the inverse. The transformation of G to the inverse. Okay, so let's see. The transformation of G of X to the inverse of f of x. So G of X is 2 to the exponent of X, and then plus 1. And then, while on the other hand, the inverse of f is what? Is 1 over 2 to the exponent of x. So before we can comment on that, we need to make sure that they have the same base, the same base, right? So the base here is 2, but we can make this 1 over 2 to have the same base 2 here. So if we can change it to what? Change this to 2 to the exponent of negative x. Now we can see that we are talking about the same base. So G of X is this one, and then the inverse of f of x is that one. Okay, so what is the transformation that occurred? Number one, we can see that changing from 2 to the exponent of x to 2 to the exponent of negative x, this is what? This is a reflection along the what? Remember, a reflection that affects the x coordinate is a reflection on the what? On the y-axis. So this is a reflection in the y-axis. So this is a reflection along the y-axis, right? Because it affected the positive x to negative x. Remember that. So whenever we have, for example, f of x now changing to g, and then now we have negative x, this is a reflection on y-axis. But then if we have f of x changing to negative g of x, this is a reflection in the x-axis. Note that, right? So a reflection on the y-axis affects the x-coordinate. A reflection in the x-axis affects the whole y-coordinate. So this is a reflection in the y-axis, and then also changing from positive 1 to our q now being 0. Remember, if we don't see anything here, it means it's 0. Doesn't mean there is no asymptote. It means the asymptote is 0. So moving from an asymptote of 1 to an asymptote of 0 means that we did what? And then this is a reflection in the y-axis, and the translation 1 unit downward. Yes, so it's a reflection in the y-axis and the translation 1 unit downward, right? So 2 marks for that. 2 marks for that. So they're just going to give you 2 marks for that. So to say it's a reflection in the y-axis, and another mark to say it's a translation 1 unit downward. Okay. Done with that. So let's move. Okay, so question 7. That's your finance. An investment earns interest at a rate of 7.5% per annum compounded quarterly. Calculate the effective annual interest rate of this investment. So we know the formula to calculate the effective rate is the original formula 1 plus I effective is equals to bracket 1 plus I nominal over the compounding period, right? Over the compounding period to the exponent of the compounding period. So we want to calculate the effective interest rate. So obviously, the first thing that we need to do is we'll take the 1 over there. So let's substitute. We have I plus the nominal interest rate is 7.5%. But note that we do not write the 7.5 as it is. Remember, it's a percentage. So 7.5 divided by 100 is 0.075. So that's what we are going to substitute here. 0.075 over compounded quarterly. So that's 4 here. And then that's a 4 right there. Then if we take that 1 and transpose it over here, that's minus 1. So we have I effective is equals to this, right? Now in your calculator, you're just going to punch all of this. And then the answer that you get, right? So the answer that you get, you immediately multiply it by 100, right? So you're going to get a whole lot of decimals. Immediately you multiply those decimals by 100. They're going to give you 7.71%, right? So that's basically how you solve that. So do not forget, after finding the answer here, you need to then multiply by 100 because you are trying to get the interest rate. And then, okay, so that means what are you going to get? Substitution into the formula, it's a mark. And then simplifying this, it's a mark. So having to simplify and then get all that, multiply by 100, it's a mark. And then having to get your answer there, right? Having to get your answer, multiply it by 100. So 3 marks, just like that. Okay, rhino poaching is a serious problem and has resulted in the black rhino becoming an endangered species. Statistics show that there were 60,000 black rhinos in 1970 and only 4,200 remained in 2011. Determine the annual rate of population decrease as a percentage over this 42 years if the rate is compound decay. Now, what is compound decay? Compound decay is the same formula as what we know as the reducing balance method, right? So that's just the reducing balance method. It's A is equals to. Remember, reducing balance method is used to calculate depreciation, but can also be used to calculate the percentage decrease of a population, right? Which is compound decay. Then we're going to say our accumulated represents the population that we're going to get over the years of or of the population decrease, right? So that's 4,200. And then the population initially was what? 60,000. And then we have 1 minus. So we have to calculate what? If the rate, determine the rate of population. So we are looking for that I. And then how many years did it take for it to come to that? 42 years. So we're going to say 42 here. So the first thing that you need to do, obviously, is to divide both sides by the 60,000 here. Right? And then you obviously going to get whatever answer that you get there. So 4,200 divided by 60,000. And then you also want to get rid of that 42 there. So now note, I'm going to do this because I'm avoiding having to round off the values. So you have to keep them in the calculator like that. And then now, in order to solve this, you need to root both sides by 42. So root 42 in your calculator. You're obviously going to punch the function that is a box here or a block, and then put the 42 right there. So at this point, what do you do? Obviously, having to do this, you'll be left with 1 minus I. And then this will be root 42. Root 42. So you're still keeping that. You're still keeping that in your calculator. 60,000, right? And then, okay, what I can do is simply transpose this negative, this one here, and then this will become minus 1 like that, right? So then what I'm going to get there is the value. So now you can punch all of that into your calculator. You can then punch all of that into your calculator. So if you punch it into your calculator, you're then going to end up with what? So that particular value, let me just punch it. Okay, so now obviously after punching all that into the calculator, you'll then have to remember to multiply by 100, which your interest rate now will be 6.14%, right? So your interest will be 6.14%, right? That's the interest rate right there. Okay, so basically that's that, guys. And then, okay, let's now move to 7.3. So they say Adam inherits 27,000, which he invests in a saving account. The interest is calculated at 5.4% compounded monthly for the full period. 3 years after he invested the initial amount, he withdraws Rx to make a down payment on a car, and then calculate the value of X if the accumulated amount is 17,614.76 in the savings account after 10 years. So they tell us that after a certain amount of time, 3 years after he withdraws an X rand of amount. Then, okay, this is how we're going to do that. We can say we do understand that firstly, the accumulated amount is what? So we're going to say the accumulated amount after that is 17,614.76, right? And then what was the invested amount? 27,000. So we're just going to use the formula A is equals to P1 plus I to the exponent of N. So we are going to have 27,000, which was invested for what? It was invested for the whole of the 10 years, right? 1 plus the interest is what? 5.4%, which is 0.054 over 12. And this 27,000 was supposed to be invested for 10 years. So 10 years is 10 multiplied by 12. That's 120 months, right? But then after a certain time, Adam withdraws an X amount. So X amount. Now we know when you withdraw an amount, it does not only get withdrawn as that certain amount, but then also along with the profit that you would have if you had kept the money. So not only do you get penalty for all of the money that you withdrew, but then also the interest that it could have accumulated. So now we are going to say minus X, but not just minus X, along with the interest, right? So we subtract that amount along with the babies. Then 0.054 over what? Over 12. And then this note, this was withdrawn after 3 years. So that means after 3 years, it loses the interest that it could have potentially gained over the remaining 7 years. Makes sense. It loses the interest that it could have gained over the 7 remaining years. So that's 7 multiplied by what? By 12, which is going to give us what? Which is going to give us 84, right? So it's that amount, subtract that amount with its interest for 84 months. I hope that makes sense. And then now at this point, what you are going to do is obviously you can take this one and transpose it over to this side. It becomes positive this, and then 1 plus 0.054 over 12 to the exponent of 84. And then it's going to be what? 27,000 and then bracket 1 plus. So I hope you have a calculator with you, and then over 12. And then now if we take this one over, it becomes minus 17,614 point what? 0.76. Now in your calculator, you just want to punch all of this. You want to punch all of that and then divide by this, right? So you want to quickly punch. Let's not forget the exponent here, 120. So the exponent over here, 120. Right. So you punch all of that into your calculator and then divide by this, right? So quickly, just punch all of that into your calculator. Then the value that you are supposed to get there is x is equals to 19,656.28, right? So that's the value that you are supposed to get. After just punching all of this into your calculator, then from finding your answer, you have to divide by this so that you get your value of x. So make sure that you punch your calculator correctly. And if you did, that's the answer that you are supposed to find. Okay, so question 7 done. So 12 marks in the bag, just like that. And then, okay, we have question 8 now. Says 8.1, determine f prime x from first principles if f of x is equals to 2 minus 3x squared, right? Okay, so what are we going to do? We're going to have f prime x is equals to lim h approaching 0, and then fx plus h minus f of x over what? Over h. Now, the first thing that I normally do is having to write my expression for fx plus h. And then this simply means where there's x, I need to replace by that, right? So x plus h and then square. This is going to be 2 minus 3. And then this usually, when we do it, it becomes x squared plus. So if you have done a lot of these questions, you already know the drill with this one. So it's x squared, 2xh, and then plus h squared, which is supposed to then give you what? 2 minus 3x squared minus what? 6xh, and then minus 3h squared. So this becomes your expression for f of x plus h, which you're then going to substitute here. Always remember to keep the lim h approaching 0 here at all times. Then this is 2 minus 3x squared minus 6xh minus 3h squared minus the expression, the original expression for f of x, 2 minus 3x squared over h. So what happens right here is that some of the terms will have to cancel, the 2 and the 2, the negative 3, negative and negative is positive, so that's when it will cancel. Then from here on, we have what? Lim h approaching 0. And then this is going to be negative 6xh minus 3h squared over h, right? And then we are going to have lim h approaching 0. Factor out the h from here. If we factor out the h, we are left with negative 6x. Factor out the h from here, we are left with minus 3h divided by h. Then what happens? This and that cancels out. And then check now. As soon as I drop this now, I am no longer using the lim h approaching 0, because now I will substitute that h by 0. So minus 3 times 0. Remember, here I still have my f prime x. So throughout here, I have f prime x, right, f prime x. And then a negative 6x minus 3 times 0. Obviously, this is just 0. Therefore, my f prime x now is equals to what? Negative 6x. Right. So there we go. So that's your first principle. 5 marks just like that. So where do you get the marks? There is a mark for having to have a correct equation for fx plus h, or a correct expression for fx plus h. Then having to substitute here, it's a mark, right? Having to find the factors like this, taking out the common factor, it's a mark. Then simplifying, it's a mark. And then now you have the answer, 5 marks. So 1, 2, 3, 4, and then 5. So that's it, guys. That's your first principles right there. Okay, then we have 8.2.1 says f prime x is f of x is equals to 2x to the exponent of 4 minus 3x plus a squared. Now note this, we are trying to derive x, right? We are trying to have the derivative in terms of x, meaning the a that you are seeing here should be treated as a what? As a constant. Anything that does not have x is a constant, right? So we know the derivative of a constant is just equal to 0. So that a squared should not trouble you there. And you should not derive it and say 2a, because we are deriving in terms of what? In terms of x. In terms of x. So this will be equals to what? For 8.2.1, we just simply say f prime x. The derivative of this is 4, jump down to multiply that. So it's going to be what? 8. And then subtract 1 from that exponent. So we are left with 3. And then this is minus what? We know the derivative of this one is just the value here. So minus 3. Then we are done. It's just like that. Just like that, we are done. And then it's a mark here. It's a mark here. And also having to see that this should have been 0, right? This should have been 0. It's also another mark, because now by not indicating it, you understand that it's a constant value and should be 0. The derivative of any constant value is 0. So 3 marks just like that. Okay, then we have this one here, 8.2.2. Now with this one, this is the one that you need to prepare for derivation first. So you can't derive while your variable is still on the denominator like that. But then we know from our maths that if we have a minus b over c, this can be written as a over c minus b over c. So we're just going to use that here to say we have 2x to the exponent of 3 over x minus root x over x, right? Now what we can do now is let's prepare this for derivation. So I'm going to say dx is 2x cubed over x. That's going to give me 2x squared. Now remember, this is inside the what you call the square root, right? It's in sub form. So that means we can write it in exponential form as this. X to the exponent of 1 over 2 and then over x, right? Now we know if we are dividing same basis, then what do? We subtract the exponents, right? So having to subtract the exponent here, still going to keep this one 2x squared. And then here, when we subtract the exponent, we are going to have 1 over 2 minus the 1 here. So we're going to keep the same base, subtract the exponent. What is 1 over 2 minus 1? It's negative 1 over 2. So we're going to have x is equals to negative 1 over 2. Now at this point, that's when we derive, because now everything is prepared for derivation. We can see that all our exponents here are in a base form, right? Or our expression is in base form. So, okay, this is 2 to the exponent of 2, which is 4x. Then minus 1 is just 1. And then here, how are we going to derive this? Negative 1 over 2, jump down to multiply the negative 1. It's going to be positive 1 over 2. And then from here, we should subtract 1. So negative 1 over 2 minus 1, that gives us negative 3 over 2. So we are going to have half x negative 3 over 2. And that's how we have our solution right there. So if you haven't got to the point where everything is prepared for derivation, you should still keep the dx and the square brackets. So a lot of you mess up with this one. So keep the dx and the square x and the square bracket up until you get to the point whereby everything is now prepared for derivation, and you derive one time, right? There is no such thing as only just deriving this part and leaving that part. You have to get it to a point where everything is now prepared for derivation and just derive everything all at once, right? So I hope it makes sense. And then, okay, that means how are we going to get the marks there? So there is a mark awarded for having to get to the stage here, right, where everything is now prepared for derivation. And then there is a mark for having to derive this part correctly and get 4x, and also a mark for having to derive that part correctly and get that. So 3 marks just like that. So, yep. Okay, so now let's get to 8.3. 8.3 says the following information is given for a function f. So we have f when x is equals to 4 gives us a value of 5, right? So the y coordinate is 5. So that means we have our coordinate as 4 is to 5. And then now again, we have that the gradient at that point, the gradient at the point when x is equals to 4 is equals to 0. Remember, f prime x stands for what? The gradient, right? So always remember that f prime x is the gradient of the curve at that particular point. Now they say, determine the equation of the tangent of f at x is equals to 4 in the form of y is equals to mx plus c. So f prime x can also be equated to the gradient of the tangent, because at that point we are saying that if the two graphs would have to intersect, and then let's say we draw that, at that point where they intersect, the gradient of this tangent is exactly the same as the gradient of the curve at that particular point. Remember, the curve has different gradients at all these points, right? So because it's a curve, it might have a different gradient here, a different gradient here, a different gradient there. But a straight line has the same consistent gradient because it's just a straight line like that. Now we are saying at the point of contact, that constant gradient of the tangent will be the same as the gradient of the curve at that particular point of contact. So meaning that we can now say the gradient of the curve at that point is equals to the gradient of the tangent. So I hope it makes sense. Now we have our coordinates. Remember, in order for us to have this in the form of y is equals to mx plus c, the two conditions is that we need to have a set of coordinates and also the gradient. We have the gradient, check. We have a set of coordinates, check. So that means to solve that 8.3, we are just going to say y minus y1 is equals to m x minus x1. Now, if you prefer the one whereby you first find the value of c and then calculate, you can still use that one. So this is y minus 5 is equals to the gradient is 7. So 7 and then x minus 4. So this is going to be y is equals to 7 times x, 7x, and then that multiplied by 7 times 4, 7, 14, 21, 28, and then plus 5, right? So y is equals to 7x minus 23. There you go. Find your equation. Or if you prefer this one, you would have said mx plus c first, and then your y is 5, and then your gradient is still 7. You have 4 here, and then plus c. So your 5 is equals to 28 plus c. Then you get your c value as 5 minus 28. 5 minus 28, which is going to give you still the negative 23. Then again, when you write it as y is equals to mx plus c, you're just going to say your gradient was what? 7x, and then your c is minus 23. So you still have the same value right there. So it's up to you which one you prefer. Do you prefer this one, or you prefer the one whereby you work out this? But then also remember, this one is provided in the formula sheet. So you might just as well get used to using that. Okay, so 8 marks just like that. We have it in the bag. We have it in the bag. Okay, so now we move to question 9. Question 9. It says the function f of x is equals to 2x cubed plus px squared plus qx plus 3 is drawn below. Now we are given n, which is the local minimum point, and then n2 is to -9 and m are turning points of f, and then g is the y-intercept of f, and a, b, c are the x-intercept of f. Show that p is equals to -5 and q is equals to -4, right? Now what we can do now is we can see that we have the coordinates here. So we can come to this equation here and say f of x is equals to 2x squared, 2x cubed plus px squared plus qx and then plus 3. And then we can simply say, what is our f of x? Our f of x, let's use the given coordinates. So where there's f of x, I'm going to have -9. Where there's x, I'm going to have the +2, right? So +2. So there's always one way to do this, right? Substitute the coordinate into the original equation. And then the next step is because the coordinate that we are given is the turning point. So the next point, you will see how we do it. So we have -9. And then right here, we are going to have what? 2 to the exponent of 3 is 8. 8 multiplied by 2 is 16. So 2 to the exponent of 2 is 4. So we have 4p. 2 times q, that's 2q. And then plus 3, 2 cubed. Then, so that means now we are going to have what? Let's have all the constants over to this side. That's -9 minus 16 minus 3 is equals to 4p plus 2q, right? So what we are going to do now is -9 minus 16 minus 3 is going to give us what? -28 is equals to 4p plus 2q, right? And then we are going to say, let this be what? Let this be equation number 1. So essentially, we don't have anything else creative to do here. Besides, we can, okay, before we do that, let's just divide everything throughout by 2 because it is divisible by 2. So -28 divided by 2, that will give us -14. This will give us 2p and then plus q. Okay, so let's just write this in the form of q. So make q the subject of the formula. -4 minus 2p. -14, meant to say, minus 2p. And then we can have equation 1. Okay, so nice. Okay, so let's hold on to that dot. And then the next part is to now do f prime x, right? So why are we doing f prime x? Because we know that if we have to have a tangent here at the turning point, we know that the gradient of that tangent would be 0. But then we know that at the point of contact, the gradient of this f prime x is the same as the gradient of the tangent, meaning that this is the point whereby we equate this to 0, right? So we can use this x coordinate here. So f prime x is equals to what? This, when we derive it, becomes 6x squared. This, when we derive it, becomes 2px, and then this, when we derive it, just becomes q. Now 3 is a constant, which means the derivative is just 0. Now remember, f prime x is equals to 0 at stationary point or turning point. So we know that the f prime x is always equal to 0 at the stationary point. So we put 0 here, 6x squared plus 2px, and then plus q. Right. But then remember that we are dealing with f prime x at which point we know the x coordinate at that point. So that means now we can just simply say this is what? 0. And then where there's x, we are going to put what? 2. Because we already know the x coordinate at that turning point. Then 2p and then 2 here, and then plus q. Right. So this is going to give us 0. Note that here we cannot substitute -9 because we are no longer using the original equation. We are now using the derivative equation, right? And the derivative equation is just simply the parabola. And then here we are going to have what? 2 to the exponent of 2 is 4. 6 multiplied by 4, that's 24. So we have 24 here. Then 2 multiplied by 2, that's 4. So we have 4p and then plus q, right? So again, our q here can be expressed as what? We can take all that to that side. This will be -24 minus 4p. I will say this is equation 2. Oh, nice. So now at this point, I can see that I have equation 1 in terms of q, and then equation 2, subject of the formula is still q. So now that means what can I do? I can equate these two expressions. I can equate these two expressions. Why? Because this is equals to q, and that is also equals to 2. So that means these expressions are equal. So I can then say equate equation 1 and equation 2, right? So which means now I will have what? I will have a negative 14 minus 2p is equals to -24 minus 4p. And then have the ones with the p on one side, that's 4p, have the constant on one side, and then plus 14. So this is going to give us what? So let's continue over here. This will be 2p is equals to what? -24 plus 14, that's -10. Divide both sides by 2, then my p is equals to -5, which is this one here. Okay, so that one down, and then to find q, we can just substitute in equation 1 or equation 2, depending on which one you would like to substitute in. But then substituting in either of the two equations must give you the same value. So to find q, I'm now going to say -14 minus 2. Then where there's p, I put the -5. So q is equals to -14 plus 10, and then q is equals to -4. So there we go. P is -5 and q is -4. And then 5 marks just like that. Okay, so where are the marks? Where are the marks? Having to substitute into the equation of f, having to understand that f prime x here needs to be equated to 0, and then substituting in f prime x, and then solving for q, right? Solving for q, it's a mark, and then solving for p, it's a mark. So 1, 2, 3, 4, 5 marks. That's it. Ah, nice, 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 nice. Awesome. So now they're saying determine the coordinates of g, the y-intercept of f. Now, obviously, we can see that this is the y-intercept here. So y-intercept is this. So that means to find g, it's just as straightforward as that. So this is the y-intercept. It's only just 2 marks. So you just say it's 0 is to 3. So they're just going to give you 2 marks for that. 1 mark for saying 0, another mark for saying 3. Wow. Then, okay. If it is given that c is 3 is to 0, oh, okay, 0 is to 3. All right. Almost got me confused there. Okay, if it is given that c is 3 is to 0, so this is 3 is to 0, calculate the distance between a and b, the x-intercepts. A and b, the x-intercepts, right? So that means here you just have to use the factor method, right? So we have our f of x is equals to 2x cube minus, remember we've already calculated p and q. So at this point, if you were not able to calculate p and q, you can still use those values and then continue getting other marks, right? So remember, focus on having to collect marks. So just replace where there's P, replace where there's Q, and then you can now continue to solve the other questions. Okay, so the factor method means that our f of x, we must remember that it's 0 because what we are trying to calculate are the what? X-intercept. So for the x-intercept, y is 0. So we're just going to put 0 here and then try to factorize this. But then remember, we are by being given 3 to 0, that means we are given a factor already there. So the factor here is x minus 3. And then x minus 3. This one, when we factorize it, it's going to be what? If we have x minus 3 there, factorizing this one, you have to say what number can I multiply with to get the 2x cube. It's obviously going to be 2x square, right? And then for the last value here, what number do I need to multiply to get positive 3? It has to be negative 1, right? So obviously the challenge is with finding the middle term here, right? So with finding the middle term, you will just do a trial and error there, and then you get your positive x here. So this is as 0 is equals to x minus 3, and then 2x squared. And then this one, if we are going to factorize the quadratic over here, it will factorize to 2x minus 1, and then also x plus 1. Remember, I did say if you can't factorize, you can still use the quadratic formula, right? And then that means here we have our values as x is equals to 3, or x will be equals to 1 over 2 when we solve this, or x will be equals to negative 1. So also there is the calculator method which you can use to find the factors, right? So there is the videos where I did this question much more broadly. So you can check out that video and try to understand how we use the factor method to find all these values here. Okay, then calculate the x-coordinate of M. Calculate the x-coordinate of M, which is the turning point of F. So where is that? So this one right there. Okay, so again, we know what to do with that one. If we are trying to calculate the coordinate of the x, we are trying to calculate the x-coordinate of the turning point. With the turning point, this is where we need to equate our f prime x to 0. So we have our f of x, originally is 2x cubed minus 5x squared minus 4x, and then plus 3. So the first thing that you want to do with the 9.4 is say f prime x is equals to what? 6x squared minus 10x and then minus 4. But f prime x is equals to 0 at turning point. At the turning point, our derivative is always equal to 0, because even here, if you have to draw a tangent line, it will exactly be horizontal and parallel to the x-axis, meaning that it has a gradient of what? This is where our f prime x is equals to 0. Okay, so now we're going to take this expression and then equate it to 0. Now we can see that all the numbers here are divisible by what? By 2. So let's divide throughout by 2. Dividing this by 2 gives us 3x squared. Dividing this by 2, 5x, and then dividing this by 2 minus 2. 0 divided by 2 is just 0. Now you can factorize, or again use the quadratic formula. If we factorize, this is 3x plus 1, and then this right here is x minus 2 equal to 0. Then this is x is equals to negative 1 over 3, or x is equals to 2. Right. So, yep. But then obviously the x is equals to 2 is for n here. So we're just going to cancel out this one and only remain with the negative 1 over 3. That's the m coordinate. So we're just going to say, therefore, the x coordinate of m is equals to negative 1 over 3. Okay, nice. So 3 marks like that. Where are we getting the marks? Where are we getting the marks? We are going to get the marks for having to say f prime x, the expression for f prime x. Now also the factors, and then also the x value. So 3 marks. Then determine the x coordinate of h, which is the point of inflection of f. Now, there are so many ways to calculate the point of inflection, right? So I will try to go through all those ways. Now, number one, you can calculate the point of inflection by simply doing this, right? So you already have your f prime x that you calculated, which was what? Which was 6x. So the original one before you divided 10x and then minus 4. Now you can get the second derivative. So that means you derive the first derivative. This will give you 12x and then minus 10. But f prime prime x, or second prime of x, is 0 at point of inflection, POI, point of inflection. At the point of inflection, you have your second derivative being equal to 0. So that means you'll have 12x minus 10 is equals to 0, which is going to be 12x is equals to 10. If you divide both sides by 12, then your x is just simply going to be 5 over 6. So 2 goes 5 times, and then 2 goes 6 times here. So that's x is equals to 5 over 6. That's method number one. Method number two, you can use this equation here, which is similar to the one that you used to get the axis of symmetry for the parabola, but this time around you have to have 3a here because of you have 3 x-intercepts, or you have 3 roots. So this is x is equals to negative. So it's more like you are trying to find the axis of symmetry between all those 3 roots. So this is b. Your b, you will get it from the formula, which is this one, right? So your b value becomes the p value over here, right? Remember, this is in the form of ax cubed plus bx squared plus cx and then plus d. So the b we are talking about is this value over here. We did calculate and we found negative 5. So negative 5 over 3. And then the a value is this one here. So that's 2. Now negative times negative, it's positive 5 over 3 times 2, that's 6. So that's method number 2 that you can use to find the point of inflection. Remember, if they now want the coordinates of the point of inflection, that means you'd have to take that x coordinate and substitute back into the original equation, meaning you substitute back into this original equation f of x. Of course, with the p and q already substituted in place. Okay, then for which values of x will f be concave up? Now, to comment on concavity, you have to have found the point of inflection, right? So now there is your point of inflection, which was what? Which was 5 over 6. Now it's just a matter of deciding, is it concave up or down right after that point, or so they want where it is concave up, right? So let's check now. Where will it be concave up? So you have your point of inflections like that. So where is it concave up? Understand what is concave up. Concave up is this. When a graph is like this, we say it's what? Concave up. And then when a graph is like this, we say it's what? Concave down. So where do we have this shape here? We have this shape right here. Note that from this point here, all the way to that point of inflection, what shape do we have? Concave down. So the graph will become concave down all the way up until this point. What is a point of inflection? A point of inflection in simple terms is where the graph changes concavity. So all along it was concave down, and then when it reaches that point, it now changes concavity and becomes concave up. So where is it concave up? It has to be from this point here going all the way to that direction, right? From this point going all the way to that direction, we can see the graph is concave up. So remember, you must write it in terms of x. So you are just going to say when x is greater than what? Than 5 over 6. And then there you go, 1 mark. So when x is greater than 5 over 6, had they said where is the graph? Concave down, right? So this is concave down. Oh, concave down. So had they said where is the graph concave down, then it would be the blue here, right? We would say when x is less than 5 over 6. So indicating that it's going to that direction. But then here, now it's going to this direction. That indicates that, right? So it's when x is greater than 5 over 6 to that direction after 5 over 6. Okay, then for which values of x will f of x times f prime x be less than 0? So now they're talking the f prime x, they're talking about the derivative equation, right? So let me just write it here. So if we're to draw the derivative equation for this one, we know that the derivative graph has to be a parabola, right? So because this is like that, the derivative looks like this. And then where the point of inflection here has to align with the turning point. So I'm trying to have a smooth curve there. So always this point of inflection here must align with the turning point. So there we go. So this here would indicate the derivative function, f prime. Now let's answer this question. Now this might not be exactly like this, but then you get the idea. For which values of x is f of x times f prime x less than 0? F of x times f prime x less than 0. In order for this to be possible, that means f of x would have to be above the x-axis and this one below the x-axis. Or f of x would have to be below the x-axis and that one above the x-axis. That's the only time we're going to have a negative, right? So the interpretation of this means that we are looking for where the graph, we are looking for where one graph is above and the other is below the x-axis. Okay, so where is one above and the other below? One above and one below. So one above and one below, we can see it right here. One above and one below happens right here at this point. So somewhere there. So we can see that if we are to extend this one here, if we are to just extend this one and then all the way like this, we can see that this will be below here and then this one will be above. So, but then what is this point here that we found? Point that we found here was what? Was a -1. And then meaning from -1 going all the way like that. Again, one above, one below. Where do we see one above, one below? One above, one below also occurs right here. Yes. So one above, one below, but then stops at this point. Because after this point, there will be both above. So again, if I can extend this, we can see that after this point, there will be both above. So, okay. So there would be both above. So in between this point and that point. But then what is the point over here? The point here is 2. You can see it's in line with that. And then the point here is the one that we calculated as the y-intercept, or the one that was given. It was 3, right? Remember, we were given those coordinates there. So 3 is to 0. Now that means it's in between here. So let's mark out those. So it's in between here. And then also from that point going that direction. So how are we going to write our answer there? For 9.7, we are going to say when x is less than -1 or when x is an element from what? From 2 to 3. So when x is greater than 2, but x is less than 3. Right. So one is above and one is below them. And then do we still have another situation? Yes. So not only that, if in here. So what do we have here? If in here one is above and one is below. See that? So if in there one is above and one is below. Okay, not even up until that point. So still here one is above up until this point. Yes. So from here to here. So, but then what was the point over here? We did calculate this one and we said it was -1/3. And then B here, we did calculate this one. It was the intercept. And then we found that it was what? It was 1/2. Right. So that intercept there. So that means we must then say again, it's in between these points. In between this point. From -1/3 to +1/2. So again, we're going to say, or again, when x is greater than -1/3, but x is less than 1/2. So, okay, those are all the answers that you're supposed to get. So it's a mark for each. Mark for this one, mark for that one, and then mark for this one. So, but then the most important thing is you having to know how to interpret. So you having to know how to interpret. So that was your 9.7. You having to know how to interpret that. So we were looking for values whereby our f of x times f prime x is less than 0, which we then said it means that one graph has to be above and the other has to be below the x-axis. Okay, nice. Let's move now. Okay, the final question now is our probability. Says 10.1, the events S and T are independent. We know about independent events. Then they say 10.1.1, calculate PT, right? Calculate PT. What is it that we know about independent events? That if we multiply them, they should give us the S and T there. So, okay, we are given P not S is equals to 3/4, right? So what can we do now? So P, S, and T is this, and then P naught is that, right? So meaning that the P of S would have to be what? So if P naught S is equals to 3/4, we know that P naught S plus P of S would have to give us what? This is based on what? Complementary events. So that is to say, if you say there's 90% chance that it's not going to rain, you are simply saying there's 10% chance that it is going to rain. So all in all, it must add up to 100%, which in probability terms, it must add up to 1. Then P of not S is what? 3/4. Then what is P of S? Is equals to 1. And then we can just say P of S will now be equals to what? 1 minus 3/4, which is supposed to give us what? 1/4. But then we are not done. Remember, we are looking for P of T here. And then what is it that we know? We know that according to independent events now, according to independent events, if we have that, we know that this is supposed to be what? P of S multiplied by P of T should give us P, S, and T. So this is based on what? Independent events. Independent events. But then what is PS? It's 1/4. What is PT? That's what we are looking for. And then what is PS and T? It's 1/6. So that means in order to find PT, we need to multiply both sides by 4 to get rid of that. Then our PT is equals to what? 4 over 6, which can simplify to 2 over 3. So there we go. So that's your PT there. So 2 over 3. Then, okay, it would be a mark for first finding PS, and then a mark for having to now substitute that PS into the formula, and then a mark for now finding PT. So, okay, 3 marks just like that. And then they say, hence calculate S or T. So, hence calculate S or T. If we then use the formula here for this one that goes PS or T is equals to PS plus PT minus P, S, and T. Right. So we are then going to say PS or T the PS is 1 over 4 as we calculated. The PT is 2 over 3, then minus 1 over 6. Right. So we can see that there's some mutual events because they have an intersection. Right. So, and then if you punch all of that into your calculator, what do you get? You get 3 over 4. So voila, you have your 2 marks like that. So substitution into this formula, and then also finding the answer, 2 marks. Okay, so that is just your grade 11 probability there. And then 10.2 says a group of 200 tourists visited the same restaurant on 2 consecutive evenings. On both evenings, the tourists could choose beef or chicken for their meals. The manager observed that 35% of the tourists choose beef on the first evening and 70% of the tourists choose chicken on the second evening. Draw a tree diagram to represent the different choices of main meals of the 2 evenings or on the 2 evenings. Show on your diagrams the probabilities associated with each branch as well as the possible outcomes of the choices. Right. So, right. This is what we are going to do now. We have the first evening and the second evening. So those are 2 events. So first evening can be indicated by this. So this is first evening and then second evening. So event 1 and event 2. So let's say first evening and then second evening. Then, or for the first evening, this is what happened. So the manager observed that 30% of the tourists choose beef. So B for beef and then C for chicken. Then B, chicken, beef, chicken. Now the probability of taking beef on the first night is what? 0.35, 35%. Right? So let's just write the percentages as a decimal. Then meaning that it leaves us what? 0.65, because these 2 have to be complementary events. When you add them together, they have to give you 1. Now the probability of choosing on the first evening, then 70% of the tourists choose chicken on the second evening. So on the second evening, the probability of choosing chicken now increases to 70%. So this one decreases to 30%. Again, when you add those ones up, they will give you 100% or 1. Then again here, 70% and 0.30. Right. So the probabilities associated with this, that's B and B. So these are the outcomes. And then 0.35 multiplied by 0.30. And then here we have BC. So you can first start by choosing beef and then you change to chicken. Then this is what? 0.35 multiplied by 0.70. And then, or you can start by chicken on the first evening, then beef on the second evening. So that's 0.65 multiplied by 0.30. Or another one can have chicken on the first night and still like to have chicken on the second night. So that's 0.65 multiplied by 0.70, right? So those are the probabilities associated with this, and then also the outcomes. Then 10.2.2 says calculate the number of tourists who chose the same meal on both evenings, right? Who chose the same meal. So the ones that chose the same meal are which ones? Are these ones here. The ones that went with beef on the first evening and beef on the second evening, or chicken in the first evening and also chicken on the second evening. So what is the probability of same meal? So probability of a same meal is a probability of B and B plus the probability of C and C. So which is going to be what? 0.35 times 0.30 plus 0.65 times 0.70. And then this will give us, multiplying this one will give us 0.105 plus multiplying this one will give us 0.455. And then this will have to give us a value of 0.56, right? Now, remember, we are supposed to calculate the number of tourists. This is only just the percentage probability, right? This is the percentage probability. Now, to calculate the number of tourists that actually did that, we have to multiply that percentage probability by the number of tourists that were there, right? So to then do that, we will take that 0.56 here. So take this 0.56 and then do what? So we're going to say 0.56 multiplied by the total number of tourists, which is 200. And then this is going to give us what? This is going to give us 112. So there were 112 tourists out of the 200 that actually decided to go with the same meal on the first night and also the second night or the second evening, right? So that's basically that. That's how you were supposed to approach all of this question right here for a total of 150 marks. So I hope you use this video to practice for your exam, which you are having on Friday. So make sure that you thoroughly go through all these questions and then use this video as a way to identify your areas of weakness and make sure that you try to strengthen on that. But then always remember, it's all about having to collect marks. So share the link with your friends and classmates so that they may also find the video and be assisted. Remember, do not be selfish. We are winning as a team.